Ultimate break, Kit Kat and Netflix.
Long time no see. Hope you're doing well. Over the last years, about the tech stack that I've been using over the let's say last 6 to 7 months actually. Maybe you want to build a SaaS product, mock-up, usually train the UX on this very soon. Code. So if you go to the website, you'll see all the success stories, which is one which to this product. But basically, this is basically a collection of brothers and sisters actually, and we are building this solution for prayer time. Tasks. What you can do is there's a bunch of features such as timetable, projects, gallery in here, Google Slides. You can actually launch the app by clicking on this button and off you go. So you can see that some machines are actually using this as beta, so it's not fully out yet, but off you go. So you can see that some machines are actually using this as beta, so it's not fully out yet, but actually using this as beta for prayer time. What you can do is
G85 5G प्राइस सेगमेंट में सबसे अच्छा फीचर है फोन में।
Incredible features.
जबरदस्त डिजाइन, 3D कर्व, OLED डिस्प्ले है, सबसे अच्छा 50 मेगापिक्सल का कैमरा है, सोनी लिथिया 600 सेंसर के साथ।
Flagship features like Smart Connect to share one of the best 5G smartphones.
Hey there, how's it going, everybody? In this series of videos, we're going to be learning how to use the pandas library in Python. So pandas is a data analysis library that allows us to easily read in and work with different types of data. So we can use this to analyze CSV files, Excel files, and other similar formats. So if you're getting into the data science field, then this library is going to be essential to learn. It's one of the most downloaded packages. Hey there, how's it going, everybody? In this video, we're going to be learning how to handle missing values and also how to clean up our data a bit. Now, almost every data set that you're going to be working with is likely going to have some missing data or data that you'd like to clean up or convert to a different data type. So we'll learn how to do all of that here. Now, towards the end of the video, we'll combine what we learn here to be able to look at our Stack Overflow survey data and calculate the average year's experiences of knowledge users in survey. So be sure to stay along with that, and it's going to be great practice for what we learn here. Now, I'd like to mention that we do have a sponsor for this series of videos, and that is Brilliant. How to draw some values. So I have my snippets file over here, and I've seen this in previous videos. And again, if anyone wants to follow along, then I have all of these notebooks and the data in the description section below. And as we've seen in previous videos, we'll learn how to do some of this in a smaller snippets data frame first, and then we'll see how to do some interesting stuff on our larger Stack Overflow data set to get this working on some real-world data. So for this video, I've added some null values here into our snippets data frame that I didn't have before. So I added some extra first names here, and we can see that I just have one that is a numpy.nan, which is a not a number value. I also imported numpy up here at the top. This one here is just a none value, and then I also have some custom missing values as well. This one is just a string of NA, and this one is just a string of missing. So I have some NAs, some nuns, and stuff like that thrown throughout this data so that we have some missing values. So you're going to see this a lot. When we work with pandas, we're going to have some missing data, and depending on what it is you're trying to do, you might want to handle this in different ways. So one thing you might want to do with missing data is to simply remove it. So for our small data frame here, let's say that we're going to do some analysis with these people in the data frame, but if they don't have their first name, last name, and email address, then we can't do what we're trying to do, so we'll just remove the rows that don't have those values. So in order to do this, we can use the drop in a method. So let's do this, and then I'll explain the results and go over those. So what I'm going to do with my data frame is I'm going to say df.drop in a, and we're going to run that without any arguments right now. So when we run this, we can see that now we only get 4 rows of data here, and up here we have, let's see, 4, 5, 6, 7. So we've got these 4 rows here because they didn't have any missing values. Now we do still have our bottom row here, which has some of our custom missing values, but we'll see how to deal with these in just a second. But for now, let's go over what drop in a is actually doing here. Now what's going on in the background is that drop in a is using some default arguments. So I'm going to manually fill in these default arguments, and it might make more sense why we got this specific result. So by default, I'll leave that one here, and now I'm going to fill in drop in a again, but I'm going to put the default arguments that it already has. And the default arguments of what this is doing in the background is it has an axis set to index and it has a how variable set to any. So since this is what the method was using by default anyway, we should just go ahead and get the same results here, and we can see that we do get the same results as we did when we ran this up here. But now let me actually explain all these arguments here. So first we have the axis argument. So this can either be set to index or set to columns. That is going to tell Pandas that we want to drop NA values when the rows are missing values when it's set to index. If we set this to columns, then it will instead drop columns if they have missing values. And we'll get to that in just a second. Now the second argument here is how we want to drop these. Or I guess a better way to frame that is this is the criteria that it uses for dropping a row or a column. So by default, this is set to any. So we're going over our rows since this is set to index, and this is set to any here. So it will drop rows with any missing values. But this might not be what we want. Maybe with this kind of analysis that we're doing, it's okay to have missing email or last name or something like that, but there just has to be something. It can't just be an entire row of missing values. So if that's the case, then we can instead change this how argument to all. And this will then only drop rows when all of the values in that row are missing. So now, if I run this, then we can see that now we get back more rows than we did before because it kept the rows that had some missing values, but not all missing values. So we can see here we have an email missing, but there were some other columns filled in. And we can see that everything was missing here, but they did have an email. So all the values have to be missing in order for this to actually drop rows. So it looks like here this index is 4. If I go up to my original data frame here, we can see that that index had all missing values there. Okay, now if I instead change this axis to columns instead of index, then it will drop columns that have all missing values. We don't have any columns that have missing values all the way down, so it should just return our original data frame. So if I say columns here and run this, then we can see that that's what we get, because none of these columns have missing values all the way down. Now, if I set this back to the default and drop columns with any missing values, then we'll actually get an empty data frame return, because we have one row that is completely empty. We saw here this index of 4. So for that row, each column is going to have at least one missing value. And if I set this to any, then any column, which is even a single missing value, will drop, which in this case is all of them. So if I change this to any, then since we have all missing values in one of these rows, that's just going to give us an empty data frame. Now at this point, you might be wondering, okay, well, my data is a bit complicated than this, and I'm doing some analysis where I want to drop some missing values, but I only want to drop rows that have missing values in a specific column. So for example, let's say that we're doing some analysis of the data, and it's fine if they don't have a first name or a last name, but we really need the email address. And if they don't have an email address, then we need to just drop those rows. So in order to do this, we can pass in a subset argument. So first, I'm going to set our axis here back to index so that we're dropping rows. And now we want to pass in a subset argument. And this subset will be the column names that we're checking for missing values. So in this case, it's just going to be a single column. So I'm going to say subset is equal to, and I'm still going to pass in a list, even though this is just a single column. And I'll say email. So if I run this, then we can see that the data frame that we get back is full of rows that have at least their email address filled in. And again, this is down here with these NA values. That is custom missing values, and I'll show you how to treat those as missing values in just a bit. Now, in this case here, since we're only passing in a single column for our subset, our how argument here isn't really doing much, because it's only going to look at the email address for missing values. So if our email address isn't filled in, then passing in either any or all for our argument here will trigger that row to be removed. So even if I put this as all, it should give us the same results, because we're only checking one value. But we can also pass in multiple columns to our subset. So what if we said, okay, well, in order for my data to be useful, I need either the last name or the email address, but I don't need both. So in order to do this, we could just say, okay, they need all of the values in last name and in email. Or I'm sorry, I got that reversed. They don't need their last name or email. It just can't be that all of those values are missing. So as long as the last name or the email is there, then it shouldn't drop those rows. So if I run this, then we can see that we get some values that don't have an email, but that did have a last name. And also, we would get back some values that didn't have a last name, but do have an email, just like this anonymous one here. It has an email, but it doesn't have a last name. And again, that's because we passed in all for our how argument, which means for a row to be dropped, both of the subset columns needed to be missing. Now, like we've seen in previous videos, this is permanently changing our data frame values. If we want to permanently change our data frame, then we have to add an in-place argument and set that equal to true here within this method. But we've seen that throughout the series so far, so I don't think I'll go over that again here. Okay, so now let's get to these custom missing values. We can see down here that we have a row here that has some customized missing values. So for example, maybe the people who got our data from didn't know what to do with missing values, so instead they just passed in a string of NA, or they passed in, a string of missing like we have here. So how would we actually handle this? Well, it depends on how we load in our data. In this case, we've created a data frame from scratch by creating a dictionary and then creating a data frame here. So what we can do here is just simply replace those values with an NA value. Now, if we instead loaded in our data from a CSV file, then we could do something different. But first, I'll show you this, and then we'll take a look at the CSV file later whenever I go over to the stack overflow data. So right here at the top, where we created our data frame, I'm going to replace these values with a proper numpy NA value. So to do this, I'm just going to go a couple of lines down here. And we've seen this in previous videos, but we can use this replace here, and I'm replacing all the values in the entire data frame. So anytime you see a string of NA, I'm going to replace that with numpy.nan. And again, I'm importing numpy up here as MP. So that's where I'm able to use numpy. And then I want to say in place equal true because we actually want to modify that data frame. So if I run that, then that will replace those values. But I'm also going to replace the string of missing as well with mp.nan values, and I'll run that in place as well. So let's go ahead and run this. That should replace those values. And now, if I look at our data frame here, then we can see that we no longer have that string of missing or NA. These are now all NA values. And now, if we go back through and run ourselves with drop in values, then these custom values should have been replaced, and it should treat those as missing values. So right here, we can see what our previous result was, where we got this index of 6 with those custom values. If I rerun this now, we can see that that's gone. And the same with here, if I rerun this, then that is gone as well. Now, if we don't actually make any changes, and we just want to see if certain values would or wouldn't be treated as NA values, then we can just run the NA or is NA method and get a mass of values as to whether or not it's classified as NA or not. So let me just show you what I mean here. So I can say df.isNA, and this is just going to give us a mask here of values that are whether or not they are classified as an NA value. So we can see that row 4 here was all NA values, and so the same thing for row 6, and we can see some other missing values throughout here as well. Now, sometimes, especially when we're dealing with numerical data, we might want to fill our NA values with a particular value. Now, I'm looking at string data here, but sometimes it might make sense to fill your NA values with certain values of these as well. So, for example, let's assume that we were calculating grades for assignments or something like that, and you had some assignments that were NA because the student never turned in the assignment. Well, at that point, you could just decide if you wanted to score all missing assignments as zeros so that you could properly calculate up the grades. So to do something like this, we can use the fill method. So for example, I could say something like this. If I do a df.fill.NA and then pass in a value, just to show you exactly what this is doing, I'm going to fill all the missing values with this capitalized missing string here. And if I run this, then we can see that all of those missing, or all of those NA values were filled with this string capitalized as missing. Now, like I said before, I don't do this a lot with certain strings. I found this to be most useful for numerical data, depending on how you're doing your calculations. But you might want to give NA values a value of 0 or -1. or something like that. So if it would make sense with your data, and you had numerical data, to replace your missing values with a 0, then you can just run df.fill 0. And go ahead and run this, then we can see that that works on our data frame as well. And again, just like with our other methods, if you want those changes to your data frame to be permanent and carry over to other cells, then simply just add that in-place argument and set that to true to make that change permanent. Okay, so now let's look at another common thing that we're likely going to need to do with a lot of our data, and that is casting data types. So I have another column in my snippets here that I didn't have in previous videos. And I have up here, if we look, this is this age column. So let's say we want to get the average age of all people in this sample data frame. Well, right now, these might look like numbers when we bring them out in our data frame down here, but these are actually strings. And we can see this if we look at our data frame data types. So to do this, we can say df.dtypes, and that's not an attribute, it's just an attribute. So if I run this here, then we can see that it says all of these columns are objects. And when it says it's an object, it likely means it's a string or a mix of different things. So in the latest version of Python, or Pandas, I'm sorry, they actually updated it so that there's actually a string data type now. I'll do a video on those Pandas version updates at the end of this series, since they actually released that updated version as I was writing this course. But don't worry, there's not a lot that's changed to where what you learned here will be outdated or anything like that. It's still mostly the same. But you can see here that the age column is a string because it's this object data type. So if we wanted the average age, that wouldn't work as it is now. So let's just see what this error looks like. So I'm going to grab the mean of that age column. And if I run this, then we can see that right now we get an error. And if I scroll down, age, that wouldn't work as it is now. So let's just see what this error looks like. So I'm going to grab the mean of that age column. And if I run this, then we can see that right now we get an error. And if I scroll down and see what this error was, it says can only concatenate str not int to string. Now that might not be the most easy to understand error right there, but basically it's telling us that because that column is strings and not integers. So we need to convert that column to numbers instead of string. Now there's a caveat how I'm doing this, and this might throw some people off. So when we have any values in a column that we're trying to convert to numbers, then you need to use the float data type. And that's because the NEN value is actually a float under the hood. Let me go ahead and show this just to show you what this looks like. So I'm going to look at the type of np.nen, and we can see that that is a float. So if we try to convert this column to integers, then it's going to throw an error when it runs into those NEN values because it can't convert those. So if I was to set df of age is equal to, and now let's try to convert these to integers. So the way that we cast data types here is we can just say, okay, I want the age column as type, and now we want to pass in the type that we want. If I try to convert these to integers, then this is going to give us an error because we have some NAE values. So we can see here, int argument must be a string, not numpy. So when you're trying to convert these to numbers and you have NAE values, you basically have two options here. If your column didn't have any missing values, then this would just work fine. We wouldn't even have this error. But if it does have missing values, then you can either convert those missing values to something else, like a 0, using the fill NA method that we saw before, or you can just pass that column to a float instead. Now, I think this would be a bad idea to convert those missing values to a 0 or some other number, because we're trying to compute the average in this case. But depending on your data, that might be what you're going to do. But I'm going to go ahead and just convert these to floats so those NA values stay missing values. So instead of an int here, I'm just going to convert this to a float. And run this, and that seems to work. So now we can look at the data types again. So I'll say df, sorry, I'm typing that cell. I can say df dtypes. And if we look at this, then we can see that now our age is a float object here. So now let's see what happens when we try to take the average of that column. So I'll say df.mean. If I run that, then we can see that we get the average value for those ages. Now, if you have an entire data frame of numbers or something like that you're trying to convert all at once, then the data frame object has an asType method as well. So you could just say df.asType and then pass in whatever data type you're trying to pass everything to, and just convert everything in the data frame at once. But we have some mixed columns here, so we don't do that. Okay, so we've been looking at a small data set right now to test this stuff out, but now let's take what we learned here and learn how this applies to real-world data and do some analysis on our Stack Overflow survey data. Okay, so first of all, I mentioned earlier that if we had custom values for missing data, then it's a little bit easier to handle these when loading in a CSV. And what I'm talking about up here is up here at the top where we replace these custom missing values. Let me show you how to do the same thing, but loading in a CSV instead. So I'm going to switch over here to my Stack Overflow survey data. Let me go ahead and rerun this just to make sure that all of this stuff is running. Okay, so this is still running, that's good. And again, this is that Stack Overflow data that we would have been using throughout the series. And if you'd like to follow along, then I do have a download link for this in the description section below. Okay, so if I wanted to ignore those custom values when loading in a CSV, then we can simply pass in an argument of a list of values that we want to be treated as missing. So here's how we do this. If we had some custom missing values here in my CSV file, then I simply create a list here of those missing values. And I will just call this in vals, and now I'll pass in a list of those. So let's say that we have some values that are a string of name and a string of missing. So now what we could do here is just add in an argument and say any values is equal to, and then a list that we just created. And if we run that, then we shouldn't get any errors. And then reads in the CSV, then we'll treat that list of values as missing values and give an NaN result. Now, this survey really did a good job of not having any weird occurrences like that, so that actually shouldn't change anything. Okay, so now let's look at an interesting problem with casting some values. So let's say that for the developers who answered this survey, we wanted to calculate the average number of years of coding experience among all of them. Now, that might be a good thing to know to compare your experience against the average, but let's look at what this, why this might be difficult to calculate with this data set. And us calculating this solution is actually going to apply several concepts that we've learned so far throughout the series. So the column to view the answer for this question in the survey is called years code. So let's look at some of these answers. So I'm just going to look at the top 10 answers for years code. So I would do a dot head, and let's look at the top 10. So if I run this, then at first glance, this doesn't really look like it'll be a problem. We just have a bunch of integers and a number of years that different respondents have been coded. So you might think that we can just grab the mean of this column simply by saying, okay, if we just have a bunch of integers here and some NaN values, that's fine. Let's just grab the mean of that column. But if I run this, then we get an error. And if I scroll down here, then it says can only concatenate string to string. And we saw the same error in our smaller data set where the column was actually being loaded in as a string instead of numerical data. And we should know how to handle this by now since we did it in the smaller data set. So let's try it. So let's try to convert this to floats and then take the average. So let me go back up here to the top of the business, and instead of running the mean here, I'm going to say, okay, well, let's convert. convert this to a float so that we can grab that average. So I will say as type, and we want to convert this to a float since there are negative values. So if I run this, then we're still getting error. So we don't get an error in a smaller data set here. So if I scroll down, then it says could not convert string to float, and the string will have number to the, so that we use the unique numbers values here. But we can see that, okay, so those are our only string values. So I'm going to replace those with numbers so that we can get an idea of the average years people have been coding. So let's go ahead and replace less than 1 year here with a 0, since that's basically the same thing. If somebody's been coding for less than a year, then they've been coding for a year. And let's replace that with a 0. So if years here. And this is going to skew our results a bit depending on how we want to do this. I'm simply going to replace this with the value of 51, and there will be that many people who have what we pick here. It could affect our results slightly. And instead, I'm going to replace more than 50 years. And I'm going to replace that with a value of 51. So now let me go ahead and run this. And if we want to look at these unique values again, then we look at these, which means that it's not actually reading this in as floats. So if we scroll back up here a bit, oh, actually, I think
G85 5G प्राइस सेगमेंट में सबसे अच्छा फीचर इस फोन में
Hey there, everybody. In this video, we're going to be learning how to handle missing values and also how to clean up our data a bit. Now, almost every data set that you're going to be working with is likely going to have some missing data or data that you'd like to clean up or convert to a different data type. So we'll learn how to do all of that here. Now, towards the end of the video, we'll combine what and the number of years that different respondents have been coding. So you might think that we can just grab the mean of this column simply by saying, okay, if we just have a bunch of integers here and some integer values, that's fine. Let's just grab the mean of that column. But if I run this, then we get an error. And if I scroll down here, then it says can only concatenate string to string. And we saw the same error in a smaller data set where the column was actually being loaded in as a string instead of numeric data. And we should know how to handle this by now since we did it in the smaller data set. So let's try that. So let's try to convert this to floats and then take the average. So let me go back up here to the top where we ran this. And instead of running the mean here, I'm going to say, okay, well, let's convert this to a float so that we can grab that average. So I will say as type, and we want to convert this to a float since there are negative values. So if I run this, then we still get an error. So we don't get an error in a smaller data set here. So if I scroll down, I also have some strings. We can get an idea of the average years people have been coding. So let's go ahead and replace less than 1 year here with a 0, since that's basically the same thing. If somebody's been coding for less than a year, then they've been coding for basically says that column. And then we can just replace that value of less than a year. And let's replace that with a 0. And we also want these to be inflated equal to true because we actually want to modify that data frame. So if I run that, then it should make that replacement. And now I'm also going to replace the value for more than 50 years here. And this is going to skew 1. So now let me go ahead and run this. And if we want to look at these unique values again, then we could look at these. And now it doesn't look as type, set that to a float. So let's run that, and we didn't get an error this time, so that's good. And now we should be able to view the average number of years of coding experience of the developers who filled out this survey. So to do this, I'm just going to say, okay, def data frame, access that column, grab the mean of that column. So if I run this, then we can see that now we get that average back. So the average that we got here was about 11.5 years of coding experience as the average years for developers who answered the survey. And now we can do other analysis on this as well. So for example, if I wanted to see the median, then I can run that, and the median comes back as 9 years of coding experience. So hopefully that real world example helps explain why it's important to cast these values and understand what's going on there. There's always going to be data that is messy or not in the format that we wanted it. So knowing how to handle these messy values and cast these values to different data types is really going to be essential when working with ANTs. Okay, so before we end here, I'd like to thank the sponsor of this. Hey there, hello everybody. In this video, we're going to be learning how to work with date and time series data within Pandas. Now, there's a ton of interesting stuff that we can do with date time data, and we'll be learning about that here. So we'll learn how to properly read in our data so that we can use date time functionality. We'll also see how to filter by date times, how to group dates by resampling the time frames, and we'll also take a look at doing some simple plotting with our time series data as well. Now, I have to mention that we do have a sponsor for the series of videos, and that is we're just using the Stack Overflow survey data for this entire series so far, but that data set doesn't actually have any date or time series data. So I had to choose a different data set for this video. I downloaded some source cryptocurrency data that we can analyze for this video, and as usual, I'm going to have links to download the data and the notebook that I'm using in the description section below. So I've got my notebook, you can see because this is segments. So if we look down here at create and download the data set using the link in the video, we'll also take a look at doing some simple plotting with our time series data as well. Now, I have to mention that we do have a sponsor for the series of videos, and that is Brilliant. So I really want to thank Brilliant for sponsoring the series, and it would be great if y'all could check them out using the link in the description section below and support the sponsors. And I'll talk more about their services in just a bit. So with that said, let's go ahead and get started. Okay, so first of all, I've been using the Stack Overflow survey data for this entire series so far, but that data set doesn't actually have any date or time series data. So I have to choose a different data set for this video. I downloaded some historical cryptocurrency data that we can analyze for this video, and as usual, I'm going to have links to download the data and the notebook that I'm using in the description section below. So I've got my notebook opened up here where I'm reading in this CSV file of data, and let's go ahead and take a look at what this looks like. So we can see here that I'm loading in this CSV file, and I called this ETH_1H, and that's because this is historical data for Ethereum, which is a cryptocurrency, and and this data is broken down in 1 hour segments. So if we look down here at the head of this data, we can see that we have some columns here. The first one is a date column, and these are broken down by the hour. We also have some other information here, like the symbols, the open and closing values for these hours, the highs and lows, and also the volume. So all of this here is for let's see, March 13th, and this is for 8 p.m., 7 p.m., 6 p.m., and so on. Now remember, if you want to see more information about your data frame. So for example, how many rows and columns there are, I can run df.shape, and we can see that there are 23,000 rows here, almost 24,000. So a good bit of data for us to work with. Okay, so now let's actually get into working with datetime data. So we have this date column here, and it looks like this is just giving us every hour of the day. But right now, this isn't actually a datetime object. I can kind of tell this just because it's not in a format that datetimes usually display at. But if you want to be sure, you can always try running a pandas datetime method on this to see if it works. So let me just grab the first row of this data frame, and I'll grab that date value. So then I'll go ahead and try to run a datetime method. So to grab that first value, I'm just going to say df.look. And we can see here that the index is just 0 over here, so I'm just going to pass in a 0. And I want to grab that date column there. So if I run what we have now, then we can see that I've plucked out that first date. So now let's just try to run a datetime method on this. So there's one method called day name that will give us the weekday that this date fell on. But if I run this now, and I say, okay, dot day name for this value here, if I run this, then we can see that we get an error, and it says that a string object has no attribute day name. And that's because we are reading this in as a string currently. So how do we convert this to a datetime? So there's a few different ways that we can do this, and we'll go over some of those here. Now, if I convert a column like we have here to a datetime, then we can use the pandas to_datetime method. So to do this, I can simply say we'll access that date column, and we'll set that date column equal to, and then we'll just say PD for what the imported pandas has, to_datetime. And now I want to pass in that same column to convert that to a datetime. Now I'm not going to run this right now, because if I run this as is, then pandas will do its best to figure out the format of the datetime and convert it accordingly. But the datetime that I have here is in a pretty different format, so I doubt that this is going to work. But let's go ahead and try it out anyway. Okay, so I expect to get an error. If we scroll down and look at the error here, we can see that it says unknown string format. So it did not know how to parse this date. But like I said before, depending on how your dates are formatted, then that might actually work for you. This just so happens to be formatted in a way that pandas can't convert this automatically without us telling it how our date is formatted. So what we need to do here is pass in a format string specifying how dates are formatted so that it can parse this correctly. Now, I went ahead and created the correct string format ahead of time for this specific date, but just to be clear, I never really remember these formatting codes off the top of my head. I always need to go and find these codes within the Python documentation. So I have that page open here, and I will leave a link to this in the description section as well. But however your date is formatted here, so ours started with the year, so we can see that that is a %y. And then we have the month, day, so we can find that here. Another one is that we have like 8 p.m. and things like that. So we can see here that these i's here, this I is for a 12-hour clock, which is what ours is doing. And then this % p is for the local equivalent of AM or PM. Hey there, everybody. In this video, we're going to be learning 1,000 rows here, almost 24,000. So a good bit of data for us to work with, giving us 8. So now let's tell them. This is a different format. String format that go to this, and you can see that that is a %y. And then we have the month, day, so we can find that here. Another one is that we have like 8 p.m. and things like that. So we can see here that these i's here, this I is for a 12-hour clock, which is what ours is doing. And then this %p is for the local equivalent of AM or PM. So those are going to be in the format string, but I'll leave a link to this just in case your date formatting is different and you need to create your own. So the format string that I need to pass in here, and again, this is basically just telling pandas how to parse our date. We're going to say that first we're going to see the year, and then a dash, and then the month, and then the day with a dash in between that, and then a space, and then %i was that 12-hour clock, and then there is a dash, and then it is %p. So let me go ahead. And if I put this in correctly, this should work. Okay, so we didn't get any errors there, but let's go ahead and make sure. So I'm going to go ahead and look at the the date column here, and we can see that now these look more like date time objects that we might be used to seeing in program. So it converted 11 p.m. to 23. Well, I'm sorry, I thought 11 p.m. was the first one. No, it's 8 p.m. Okay, so it converted 8 p.m. to 20 and 7 p.m. to 19 and so on. And now that this is converted to a date time, we should be able to run these date time methods that gave us an error before. So up here where we got this error, where we tried to grab the day name for these, I'm just going to copy that and paste that in down here. And now let's try to rerun this. And we can see that now it's saying that that first date in our series here, this March 13th, was a Friday. Okay, so that's nice. So it looked like it works. Now the way that we did this here is that we converted this to a date after we loaded in our data with this line right here. But if we wanted to convert this to a date as we're loading in the data, then we can also do that as well. So if I go up here to the top where we loaded this in at this read CSV line here, then I can actually pass in some arguments to read CSV so that it loads in certain columns as date times, and then we can pass in our formatting string as well so that it parses those as the data is read. So to do this, we need to pass in this parse dates argument here, and then I'm just going to pass in a list of the columns that are going to be dates. We only have one here, so it's just going to be a list of one item. Whoops, and I need to put date, not dates. And now, just like with before, if your dates are already formatted in a way that pandas can parse them, then you don't need to add anything else here. But we already saw before that we need to pass in a specific format. So to do this here, we can't just pass in a format string. We instead need to pass in a function that converts each string to a date time object. So first, let's create that function. And we've seen lambda functions in this series before, but just in case you're unfamiliar with those, you can simply create a normal function instead if you are more comfortable with those, but this is just a shorter way. So to create this lambda function, I'm just going to call this d underscore parser. I'm going to set this equal to a lambda function, and I'll just use x as a variable here. And now what do we want to return? So when we used pd.toDateTime, we actually passed in an entire series to pd.toDateTime. But now this is actually just going to be each individual string, and it's going to send each individual string through this function. So in order to convert this, we can use a function called pd.datetime.strtime. That's how we convert a string to time. And then we can just pass in our string that we want converted to a date time. And then the format. And I already had the format down here, so I'll just go ahead and copy that and paste that in here. And that's all we need for that date parser function. So now the argument for the date parser is date underscore parser, and I'm going to set that equal to that d parser variable there that is set to our lambda function. Okay, so now if I run this here, then we can see that we didn't get any errors, so that's good. Now if I run this df.head here, then we can see that now our data frame was already loaded in as a date time. So we didn't have to do any conversions later on. It just did it as it was reading in. that CSV file. Okay, so now let's look at some more useful things that we can do with date times. So first, I'm going to delete the cells that we have below here so that we are not converting these columns again since they're already loaded in as dates. So I'll delete that one. I will delete that one since that was what was converting it earlier. I'll delete that as well. And I'll keep this one here just for reference since I will have these up on my GitHub afterwards. Okay, so before, actually right here, we saw how to run a datetime method on a single value when we use this day name method. But what if we want to run that method on an entire series? So let's say that we wanted to view the day name of this entire date column here. So to do this, we can access the DT class on the series object.
Hello guys. Hello guys, this is Dara. If you are new to English, assist change logic is correct. Loading a logistic regression model in the variable var. And the function model graphic model is string. It is just like a graph. Okay, so in the x-axis there will be these features and on the y-axis there will be layers. Okay, and the graph will be plotted. So this is our model string. So once we are training the model using function model graphic, we are finding the accuracy score. So first we find the accuracy score of training data, which is around 8. Write all this Python script by your own and try to understand it. So if you have any doubt, if you hello everyone, this is Siddhartha. Welcome to my YouTube channel. In this video, I would like to explain about the curriculum for my hands-on machine learning course with Python that I am publishing on YouTube. Okay, so I have given the link for my YouTube channel in this document file, and you can get the link for this particular file in the description of this video. Okay, so first of all, let me tell you about the schedule in which I post the videos in my channel. So in a week, I will be posting 3 videos.
and access the datetime methods that way. So to do this, we can just say, we can first grab that series. So that date column is going to return a series. If I run that, we can see that we get all those values. And now, if we wanted to access the DT class on the series object, then we can just say .dt, and now the datetime method that we want to use. So if I want to get the day name of all these values, then I can just do day name there, and if I run that, then we can see that we get the day of the week for each of the dates in this series. So using the DT class on the series object is very similar to how we access the string class or the str class for the string methods on an entire series, and we saw that in previous videos. So this can definitely be pretty useful. So let's say that we wanted to, create another column so that we could quickly reference what day all of these traits took place. So to do that, we could just grab what we have here, and I could simply create a new column by simply like I'm accessing the column, just grab another column so that we could quickly reference what day all of these traits took place. So to do that, we could just grab what we have here, and I could simply create a new column by simply like I'm accessing, we could just grab what we have here so that we could quickly reference what day all of these traits took place. Let's say that we wanted to, create another column so that we could quickly videos. So this can definitely be pretty useful. So let's say that we wanted to, create another column so that we could quickly reference what day all of these traits took place. So to do that, we could just grab what we have here, and I could simply create a new column by simply like I'm accessing the column. So I can call this column day of week and set this equal to, and paste in that datetime method there. If I run this, and then we look at our data frame, then we can see that now we can quickly see over here on the right that, okay, the 13th was a Friday, and then we have these dates down here towards the end. This was a Saturday. So it's nice to see, or be able to see what days these traits actually took place. So now let's look at how we can explore our data a bit. So we can see by looking at the indexes here on the far left that there are over 20,000 rows in this data set. So let's see how we can view the earliest and latest dates in this data. So to do this, we can use the min and max methods. So to see the earliest date, I could simply access this date series here, and I can just run the min method on this. If I run that, then we can see that the earliest date that it gives us is 2017 0701. Now I wanted to see, so what is that? That's July 1st of 2017. So to view the most recent date that I have, and it should be the date that I downloaded this data, then I can just look at the max value here, and if I run this, then we can see that this is March 13th, 2020, which actually was the day that I downloaded this data. And the really cool thing with date times is that we can actually subtract dates in order to view the time between those two dates, and this is called a time delta. So to get the amount of time that spans between these two dates here, then I can simply say, take the max value and then subtract the min value, And if I run this, then we can see that we get this time delta that says that there were almost 1,000 days between the earliest date in our data set and the most recent. So we have 900. 86 days in this entire data set of cryptocurrency data, almost 1,000. So that would definitely be a lot of days to look through if we want to find some specific ranges. So what if we wanted to do some filters by date? So for example, let's say that we just wanted to view the data for 2020. Now that we have these converted to date times, we can create filters just like we have in previous videos, and we should be able to use strings that are formatted like date times, or we can use actual date time objects. We'll take a look at both. So let's see an example of this in some code so that it makes some more sense. So first, I'm going to create a filter in a separate variable like I've done in previous videos, but you can also do this in line if you prefer to do it that way. I just think that creating our filters separate is a little bit easier to read. So let's say that I want our date series. I want the objects or the rows that are greater than, and then I'm just going to pass in a string here for now, and I can just pass in a 2020 there, and Canvas will know that I'm talking about the year 2020. Let's actually do a greater than or equal to here. Okay, so now that I have that filter, let's just do a df.loc. Again, we've seen this in previous videos, and then I'll pass in that filter. So if I run this, then my bottom row here should be January 1st of 2020, and it is. And we can see that we have 17,000 hours here of 2020 data, or I'm sorry, that's 1,700 hours of 2020 data. Okay, so the reason that this doesn't go above 2020 is simply because, our latest data runs out, so we're not getting 2021 since 2021 hasn't happened yet. But what if we wanted data for 2019? Well, in order to do that, we'd also have to put in an upper bound as well. So to do that, I'm going to say, okay, we want our data to be greater than or equal to 2019, and we're just going to do an ampersand there. I'll go ahead and copy this here, and then just replace this with a less than, and we'll say less than 2020. If I run this, then we can see that bottom row here, we have January 1st of 2019 at midnight, and then our top row here is December 31st at 11 p.m. of 2019. So that gives us all the rows of data that we have for 2019. And right now we're just using strings up here for these comparisons, but we can use actual date times as well. So to do that, we could actually say, I could just say pd.datetime. Then let me go ahead and pass in the month and day here as well. So I'll say that I want this to be greater than 2019, January 1st. And then I'll just grab this here and replace this 2020. And then I'll say, but I want this to be less than 2020's January 1st. So now, if I run this, whoops, and I got an error here. It says, community rules required data string. That might not make sense. What I did here is, I don't want pd.datetime. That's my mistake. I want to do the same thing that we did before and do toDatetime, so that it converts the string here to a datetime. So let's do pd.toDatetime for both of those and run this. And now we can see that we get those same results as before for all of the rows in 2019. Now, one nice feature about dates is that we set our index so that it uses the date, which would actually be a good idea for this data set, since all of these dates or timestamps are unique. Then we can actually do the same thing by using slicing instead. So let's see what this looks like so that it makes more sense. So first, let's set our index so that it's using this date column here. So here at the bottom, I'm going to say df.set_index, and then I'm going to pass in that I'm going to set the index to date. And if I run this, then that looks good. We have set our index to use date here, and now that looks good. It actually didn't make that change. I want to say in place is equal to true to make that change permanent. So I'll run that. And if I run this, then using this date column looks like so that it makes more sense. So first, let's set our index so that it's using this date column here. So here at the bottom, I'm going to say df.set_index, and then I'm going to pass in that we want to set the index to date. And if I run this, then that looks good. We set our index to use date here, and now that looks good. It actually didn't make that change. Then that looks good. We set in that we want to set the index to date. And if I run this, then that looks good. We set out that we want to set the index to date. And if I run this, then that looks good. We set our index to use date here. And now that looks good, it actually didn't make that change. I want to say in place is equal to true to make that change permanent. So I'll run that. And if we look at our data frame again, then now we have that date as our index. And now with that date index, we can actually filter our dates just by passing them into our brackets. So if we wanted the that, and if we look at our data frame again, then now we have that date as our index. And now with that date index, we can actually filter our dates just by passing them into our brackets. So if we permanent. So I'll run that, and if we look at our data frame again, then now we have that date as our index. And now with that date index, we can actually filter our date. Dates just by passing them into our brackets. So if we wanted the data for 2019, then I could literally just say that I want the data here for 2019, pass that into my brackets. If I run that, then we can see that we get the same thing here. We get this value for January 1st. Then from that, then we can see that we get the same thing here. We get this value for January 1st, and then the top value here is for December 31st. So it's a bit easier to just access these within brackets when these are indexes, rather than creating a filter. Now, if you want to grab dates for a specific range, then you can use a slice. So let's say that we wanted all of the data for January and February of 2020. So to do that, using this slicing. Now, if you want to grab dates for a specific range, then you can use a slice. So let's say that we wanted all of the data for January and February of 2020. So to do that, using this slicing here, then I can say, okay, I want from 2020-01, which would be January, and then I could just do a slice here using that colon, and then say, okay, well, I want to go up to February of 2020. So if I run this, the second value here is inclusive. So we can see that we have January 1st of 2020 down here at the bottom, and that slices all the way up to February 29th, since this was a leap year. Now, this can be really useful for analyzing our data, because let's say that we wanted to get the average closing price for Ethereum for all of our rows of these dates. To do that, we can simply grab this closed column here, and then grab that average, or grab that mean. So to do that, we can just say, let me copy this part here. First, let me just access that closed series there, that column. If I run that, then we can see that we get all of these dates. To do that, to February 29th, since this was a leap year. Now, this would be really useful for analyzing our data, because let's say that we wanted to get the average closing price for Ethereum for all of our rows of these dates. To do that, we can simply grab this closed column here, and then grab that average, or grab that mean. So to do that, we can just say, let me copy this part here. First, let me just access that closed series there, that column. If I run that, then we can see that we get all of those closing values on each of those hours for all of those days. And now to get the mean of that, I can just say dot mean. And that gives us the average closing price for all of those rows within that time frame. And remember, each of those days is reported by the hour. But what if we wanted to column? If I run that, then we can see that we get all of those closing values on each of those hours for all of those days. And now to get the mean of that, I can just say dot mean. And that gives us the average closing price for all of those rows within that time frame. And remember, each of those days is reported by the hour. But what if we wanted to see this data in a different way? What if we instead wanted to look at this data on a daily basis instead of on an hourly basis? Well, first, we need to think about what would make sense to view on a daily basis. So, for example, let's say that we wanted to, view the highs for each day. So right now we have all of these highs broken down by hour. Let me actually look at the first. Let me grab this date range here. And let's look at the first 24 of these so that we can get 24 hours here. So we can see that for February 29th, we have all these different hours here, and each hour has a different high value. But what if we were like, okay, well, we see all these different high values here, but what is the highest value of the day? So actually, let me just grab a single day here, and then we will look at the high values for that. So instead of doing all of these dates here, I'm just going to grab January 1st of 2020, and then we will look at the high values for that day. So again, we don't really care what the highs are for each hour of each day. We just want to know the high for the entire day. So to do this, all we need to do is grab the max value for the dates here. I'm just going to grab January 1st of 2020, and then we will look at the high values for that day. So again, we don't really care what the highs are for each hour of each day. We just want to know the high for the entire day. So to do this, all we need to do is grab the max value for this series. And we saw how to do this. It's just like running mean right here. All we have to do is say .max, and if I run that, then we can see that the high value for that day was 132.68. Okay, so let's remember this value here right now, this 132.68, because we're going to see how we can resample our data so that we can get the highest trades for each day of our data. And then we'll use this one here to compare for January 1st of 2020. So again, right now, our data is broken down on an hourly basis. So if we want to redo this so that it's instead broken down by day or week or month, then we'll do this by doing something called resample. So let's see what this looks like. So if I want to resample this and see the high value by day, then I can simply access this high column here. And then on that series, I can say, okay, I want to resample this. And now we have to tell resample how we want to resample this data. Right now it's hourly. If I put in a D, then it resamples it to days. And I can do 1D or 2D. You can do whatever. You can do a W for week. There's all kinds of different codes here. Now, just like with these datetime formats, I hardly ever remember these, so I always need to look them up in the documentation. So I've got this pulled up in the Pandas documentation here for these date offsets, and I will leave a link to this page in the description section below as well if you all would like to try out some of these. We can see we have hour, minute, second, milliseconds, microseconds, all kinds of things. If you're doing finances, you can do quarterly and things like that. So I want to do this on a daily basis, so I'm going to put a D there. And now we have to tell it, okay, well, what do we want to do with these resamplings? If I'm looking at entire days here, so if I take this entire day first, what do I want to do with this high value? And we're just saying, well, we want the max value for each of those days. So if I run this, then we can see that that gives us a series with all of the high values for each day. So now let's save this series here as a new variable and look up the specific date that we used before. So I'm going to save this as a variable and call that highs, and then let's access that specific date of 2020 0101 for the highs. Now, what we should get here, since we're using the same date that we did here, we should get this value of 132.68. So if I run that, then we can see that the high for that day was in fact equal to what we did here, so that works. But now, instead of just getting one day at a time like we did here, now that we've resampled this, now we have those high values for every single day in our data. Okay, so why would something like this be useful? I mean, that may be useful just because it's interesting, but there are other things that we can do as well. So let's say that maybe we wanted to plot this out, but instead of viewing a plot that had these prices broken down hour by hour, now we can just do a plot for the total price broken down by day. So within Jupyter Notebooks, it's extremely easy to plot out information. I'm actually going to do an entire series on plotting with pandas, so I'm not going to go into a ton of details in this video, but we will see how we can do a very simple line plot here. So to do this, we first need to use this special line within Jupyter Notebooks. Is a here. Plotted out. Okay, so that's pretty nice for just plotting this out at once. I mean that we set resample and different time period. What is to run what to use, and then I'll say in function weekly high and volume is data that do a deep dive on how to think about and analyze data correct, weight them out. So in this series, they have some excellent courses in statistics, and like I said, being in the comment section below, and I'll do my best to answer those. And if you enjoy these tutorials and would like to support them, hey there, how's it going, everybody? In this video, We're going to be learning how to read and write data to different sources. So we'll learn how to read and write data using CSV files, Excel files, JSON, and also SQL databases. Now, in this series so far, we've been reading data from CSV files, but in data science, there are so many different ways for data to be stored. So by the end of this video, you should be able to get your data to and from Pandas, no matter what data format you're using. Now, if you're watching this video because you're looking for how to read and write a specific file format, then be sure to add timestamps in the description section below. Hey there, how's it going, everybody? In this video, we're going to be learning how to work with date and time series data within Pandas. Now, there's a ton of interesting stuff that we can do with date-time data, and we'll be learning about that here. So we'll learn how to properly read in our data so that we can use date-time functionality here. Then we can say matplotlib inline. Now, one thing that I do want to mention, this high column here, and on that series, I can say, okay, I want to resample this. And now we have to tell resample how we want to resample this data. Right now it's hourly. If I put in a D, then so again, we don't really care what the highs are for each hour of each day. We just want to know the high for the entire day. So to do this, all we need to do is grab the max value for this series. And we saw how to do this. It's just like running mean right here. All we have to do is say .max. And if I run that, then we can see that the high value for that day was 132.68. Okay, so let's remember this value here right now is 132.68. Because we're going to see how we can resample our data so that we can get the highest trades for each day of our data. And then we'll use this one here to compare for January 1st of 2020. So again, right now, our data is broken down on an hourly basis. So if we want to redo this so that it's instead broken down by day or week or month, then we'll do this by doing something called resample. So let's see what this looks like. So if I want to resample this and see the high value by day, then I can simply access this high column here. And on that series, I can say, okay, I want to resample this. And now we have to tell resample how we want to resample this data. Right now it's hourly. If I put in a D, then it resamples it to days. And I can do 1D or 2D. You can do whatever there. You can do a W for week. There's all kinds of different codes here. Now, just like with these date-time formats, I hardly ever remember these, so I always need to look them up in the documentation. So I've got this pulled up in the Pandas documentation here for these date offsets, and I will leave a link to this page in the description section below as well if you all would like to try out some of these. But we can see we have hour, minute, second, milliseconds, microseconds, all kinds of things. If you're doing finance, you can do quarterly and things like that. So I want to do this on a daily basis, so I'm going to put a D there. And now we have to tell it, okay, well, what do we want to do with these resamples? If I'm looking at entire days here, so if I take this entire day of the first, what do I want to do with this high value? And we're just saying, well, we want the max value for each of those days. So if I run this, then we can see that that gives us a series with all of the high values for each day. So now let's save this series here as a new variable and look up the specific date that we used before. So I'm going to save this as a variable and call that highs. And then let's access that specific date of 2020. 0101 for the highs. Now, what we should get here, since we're using the same date that we did here, we should get this value of 132.68. So if I run that, then we can see that the high for that day was in fact equal to what we did here, so that works. But now, instead of just getting one day at a time like we did here, now that we've resampled this, now we have those high values for every single day in our data. Okay, so why would something like this be useful? I mean, that might be useful just because it's interesting. There are other things that we can do as well. So let's say that maybe we wanted to plot this out, but instead of viewing a plot that had these prices broken down hour by hour, now we can just do a plot for the total price broken down by day. So within Jupyter Notebooks, it's extremely easy to plot out information. I'm actually going to do an entire series on plotting with pandas, so I'm not going to go into a ton of details in this video, but we will see how we can do a very simple line plot here. So to do this, we first need to use this special line within Jupyter Notebooks that allows our plots to display within the browser. So all we have to do is say, this is a percent sign here, then we can say matplotlib inline. Now, one thing that I do want to mention here is that I did have to go and install matplotlib in the virtual environment that I'm using. So if you've only installed pandas for that, and that's it. then you might want to go back and install matplotlib, or else you'll get an import error here. I went and installed that in my virtual environment, so we can see that that worked there. And if that one line of code there, now we can display plots directly within our Jupyter Notebook. So I can simply run a plot method on this data frame variable that was resampled and get a plot of that. So I'm just going to say, okay, I want highs plotted out. So highs.plot, I'll run that, and we can see that we get a nice matplotlib plot here. Okay, so that's pretty nice for just a few lines of code there. Now, one thing that you might be wondering is if it's possible to resample multiple columns at once, and we can do that by running the resample method on our entire data frame instead of on a single series. So, for example, what do I mean by this? Okay, so whenever I say resample multiple columns at once, I mean that what if we wanted to resample this by day? So far, we've only seen how we got the high value. But what if we said, okay, well, I want to resample this by day, but I also want the average closing cost of that entire day. I want the sum of all of these volumes for that entire day, and then I want the max high value, and I want the min low value. So the way that we've done it down here, where we just access that single column, we wouldn't be able to do it using this method that we did here. So in order to resample and use multiple columns like that, here's how we can do this. So we can do this by running the resample method on our entire data frame. So if you want to use the same aggregation method on all of your columns, so for example, let's say df.resample. So now we're resampling our entire data frame object here. And now we're going to pass in what we want to resample on. Instead of day, let's change it up and do week. Now we'll resample by each week. So if you want to use the same aggregation method on everything, then you can just put in that aggregation method there. So if I run this, then this is going to give me the mean values for each of our columns on a weekly basis. Now, this is cool that we can do this, and sometimes you might want to do something like this. But in this instance, it doesn't really make sense to use mean to get the average of all of our columns. So for example, there's no real reason to get the average volume per hour or something like that. You probably want to get the sum for the entire time period. Or for our high and low values here, these are giving us the average highs and the average lows. But the point of a high and low value is to know the high for that time period and the low for that time period. So we probably don't want mean here either. So how can we resample this to where we can resample and use multiple columns, but also use multiple aggregation methods? Now, we've actually seen this in previous videos and used this method. But what we want to use here is the AGG, the add method. And the add method also accepts a map of columns and the aggregation functions that we want to run on that column. So for example, let's do this with the values for, let's see, we'll do the closing column, we'll do the high and low columns, and then we'll also do the volume here. So I'm going to grab this from up here, and Then we'll do df.resample, and we'll pass in a w for a weekly basis. And now, instead of passing in .mean, like we did up here, I'm going to pass in .agg, and now I can pass in a dictionary of the columns and or the column names, and then the values will be the aggregation function that we want to use on that column. So for example, let's say that for the closing value, I do want to grab the mean of that, and then I'll say for the high column, I want to use the max aggregation function for that. Since we want the max value for the lower column, I want to get the min, and for volume, I'll go ahead and just sum up all of the for that entire time period. Okay, so again, the keys here for this dictionary we passed into the app, this is the column name here, then this is the aggregation function. So we're taking the mean of closed. We're taking the max for this entire weekly period here, for the highs, the min for the low, and then sum for volume. So if we run this, then it gives us this nice weekly overview of the weekly highs and the weekly lows here, and also the average closing costs here, and we also have the summation of the volume of trades. So this really touches on what we can do with date time and time series data in Pandas. Like I said a little bit ago, I do plan on doing a full series on Pandas plotting, where we'll cover more advanced topics, such as plotting things out and having rolling averages for data and things like that. Now, before we do end here, I do want to thank the sponsor of this video, and that is Brilliant. And I really enjoy the tutorials that Brilliant provides, and I definitely recommend checking them out. Hey there, how's it going, everybody? In this video, we're going to be learning how to read and write data to different sources. So we'll learn how to read and write data using CSV files, Excel files, JSON, and also SQL databases. Now, in this series so far, we've been reading data from CSV files, but in data science, there are so many different ways for data to be stored. So by the end of this video, you should be able to get your data to and from Pandas, no matter what data format you're using. Now, if you're watching this video because you're looking for how to read and write a specific file format, then we have a sponsor down how to write. So to do this, .to.csv, now call this modify.csv. So if I run this, we can see that we don't get any errors. And now if I go back and look at my file system here, then I have this modified.csv. And now if I go back and look at my file system here, then I have this modified.csv file. I can see in India for that all of our this is a little bunched together since it's a CSV file result tabbed. So we can write to a tabbed loaded file in CSV methods that we've already seen, but we want to pass in a custom separator. So we can write to a tabbed loaded file. We're going to specify a separator argument. So so I'm going to put a backbone on that. Then we can to all this. So now let's move on to some Excel environment that I am using. This is my Jupyter notebook running here. Let me grab your Pippin's and Excel format. But finally, so I think that it let those finish. So to write to underscore Excel method list modified, I run this, then we can tell it there, and we can see that I do have that dot here, just going to find, for example, the concept of passing a scroll down to the buttons. This method that when we read. So that column equal to responding. So I'm going to run that cell and load that in. And then I'm going to look at that test data frame, time B. So if I look at the head, then I can see that we have the same data frame here that we have up here. So that was exported to Excel and imported time data. So let's take a look. We can use the default arguments, send a file location here, but instead of an Excel file, we want a JSON file. Now I'm going to use the default. If I go back to my data folder here, then now we have this JSON lot of data in here. If I look within here, okay, that took just a second to open up on my machine. Again, we do have a lot of data in here. If I look within here, okay, that took just a second to open up on my machine. Again, we do have a lot of data in here. But if we look in here, then we can see that this is very dictionary-like. So we have a main branch scroll down here that will be able to find the other key different. And this lines equal to true, let me spell that right. We'll just make each of the sender. The values were a list of all of the responses. This is actually this first one here. If I scroll down, you can see that this is the second response. This one. And we can read underscore JSON location. We know that the order data, you might need a Postgres with Excel. Shutting down here. Let's see, let me try to go back to terminal here. For Python, and it's just SQL alchemy here. So for example, if I go, let's port to want to create the engine. So the password for the databases, which is table. It's good that we were able to column to be JSON. I can just paste web URL towards by active. Also have the ability to get hints or even get .org pre in. So he's already covered asking a quiz through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos. Thank you all so much. Hey there, how's it going, everybody? In this video, we're going to be going over a handful of useful tips and tricks in Python that I think will help you write some better code. Now, these are topics that I've already covered in other videos, but a lot of them don't require an entire video to themselves, so instead, I've compiled together a list that I think you'll find most useful. Now, I do have a sponsor for this video, and that is Skillshare.com, so I'd like to thank them for supporting the channel, and it'd be great if you all... Hey there, everybody. In this series of videos, we're going to be learning how to use the matplotlib library and Python. So matplotlib is a plotting library for Python that allows us to create some great looking graphs from our data. So this is used a ton in the data science field and also in applications where we need to visualize our data. So I have the matplotlib website over here, and you can see on our example page that you can make some really nice visualizations. Hey there, how's it going, everybody? In this video, we're going to be going over stack plots, and you may have also heard these called area plots. They're very similar. Hey there, how's it going, everybody? Hey there, how's it going, everybody? In this video, we're going to be plotting data that's continuously being generated in real time. So these real-time plots would be great for plotting data that's changing frequently that you want to monitor. So for example, import here. So the reason it's doing that is because writing that row. It's going to be all of the, I think it's usually just start writing data back to this. You can also try to include that in the snippets for this video when I upload those to GitHub. So you can probably find those there if I don't forget. Okay, so that...
Hello guys, this is Siddharthan. If you are new to this channel is all about artificial. Hello guys, this is Siddharthan. If you are new to this channel is all about artificial intelligence and machine learning stuff. So this channel will be posting 3 videos for you. So 2 videos will be about basics of machine learning, so basic concepts and topics, and 1 video will be a detailed use case or project in machine learning. Okay, so the basic video will be posted on Monday evening or Wednesday evening, and the project video will be posted on Friday evening. Okay, so in this video we are going to discuss about one of the interesting use cases in machine learning. So it is raw process mind prediction using small data. Okay, so we will do all the programming in Python, and you don't need to install any Python software. So we will be using Google Collaboratory. So Google Collaboratory is a cloud-based system that can make your Python script. So you just need Google Chrome for it. So I will show you how you can access it later in this video. First of all, let's try to understand more about this use case. Consider there is a submarine. Okay, so there is a war going on between 2 countries. So somebody in one country is going in the underwater to another country, and the enemy country have planted some mines in the ocean. Okay, so mines are nothing but the explosives that explodes when some object comes in. in contact with it, right? So there can also be rocks in the water. So the submarine needs to predict whether it is crossing a line or a rock. Okay. So our job is to make a system that can predict whether the object beneath the submarine is a line or a rock. Okay. So how this is done is the submarine sends a sonar signal. Okay. So the sonar uses a sonar that sends sound signals and receives it back. So this signal is then processed to detect whether the object is a line or it's just a rock in the water. Okay. So let's try to understand how we are going to do this. First of all, let's see the workflow of this project. First of all, we need to collect the sonar data. Okay, so how this data is collected? So what happens is in the laboratory setup, an experiment can be done where the sonar is used to send the receive signals bounce back from a refrigerator and some rocks. Hello, this is data. This is our whole project. Hello guys, this is the news so going on to the tasks in the water. Our job is to make a system that can predict whether the object beneath the submarine is a line or a rock. Okay, so how this is done is the submarine sends a sound signal. Okay, so the sonar uses a sonar that sends sound signal and receives it back. So this signal is trying to understand. We will process the data. So we cannot use the data directly. So we need to pre-process the data. So whenever the data going to our signal data. Okay, so how this data is collected? So what happens is in the laboratory setup, an experiment can be done where the sonar is used to send the receive signals bounce back from a metal cylinder and some rocks. Okay, so because the lines will be made of metals, right? So we collect this data, which is nothing but the sonar data which we obtain from the rock and the metal cylinder. Okay, and we use this sonar data and we feed the sonar data to our machine learning model, and then our machine learning model can predict whether the object is made of metal or it is just a rock. So this is the principle we are going to use in our prediction. Okay. So first we need to collect the data. Okay. So once we have the data, we will process the data. So we cannot use the data directly. So we need to pre-process the data. So there are various steps in that which we will do in this video. So we need to analyze the data. So we need to understand more about it. So once we process the data, we will split it into training and test data. Okay. So why we are splitting the training and test data? Because so let's say there are 100 examples, so 100 instances of data. We will train a machine learning model with 90 instances, and we will test the machine learning model. So we evaluate our model with another 10 data points. Okay, so there are only 10 or 100 data points. We will use 90 data points for training, and we can use another 10 or 20 data for testing our model. Okay, so once we split our data into training and test data, we feed it to a machine learning model. So in this video stage, we are going to use a logistic regression model. We call logistic regression works very well for binary classification problem. So this problem is a binary classification problem because we are going to predict whether the object is rock or line. Okay, so we use logistic regression model, and this is a supervised learning algorithm. Okay. So once we train our machine learning model with the training data, we will get a very logistic regression model. So this model has learned from the data on how a metal cylinder is behaving and how so this model can recognize it based on the sonar data. Now when we give a new data, it can predict whether the object is just a rock or it is a line. So this is the workflow we will be following in Python to make this script for this use case. Okay. So now let's go into the coding part. So before that, I will show you the data here. Okay. So this is the data, .csv. So it is a CSV file. So you can find this data in add other data types like XML, repositories, or websites. So I'll be giving you a link for this file in the description of this video. Let's try to look at this video for this data. So as you can see, Hello guys, this is Siddharthan. Here there are a lot of numbers. So there are a lot of columns. So let's see there are how many instances. So there will be almost 200 examples. So as you can see here there are 208. That means 208 data points. So in the last column we have something that tells R and M. Okay, so R represents the values for R and M represents the values of mice. Okay, so as I told you earlier, this values are obtained in a laboratory setup where the sound data is collected for reference data and for so I can see here there are several features. So some features are present in the columns of this data set. So we feed this data set to our machine learning model. We can learn from this data on how a dog can be and how a mind can be with the help of this sonar data. Okay, so let's see how we can make this Python script. So I close this. So I told earlier we will be doing our programming in Google Collaborate. So search for Google Colab. You just need to choose Colab, click on notebook, so by name. So go ahead and connect this. Go to the next test to do it. So this is usually fine for that environment. So then we have this application. There are several ways to upload data in Google Collaborate. They already upload and I don't get very good train us in this. So I import numpy assembly. So import numpy assembly and we also need pandas. So import pandas as PD. Okay, so numpy is basically for for arrays and pandas is for several data functions. So we will see about that later. Now we need train test split. Okay, so we have seen earlier that we need to split our data into training data and test data. So we will require a function for that. So from skl dot model selection import train test split. Okay, so this function is used to split the data into training and test data, so we don't need to do it manually. Okay, so then we need a domestic iteration mode. So skl is a very good Python library for machine learning algorithms and other functions. So you can encounter it in various different places here. There is a small mistake here. SQL dot so import train just split. Now we need to import the logistic regression model. So SQL dot linear model. So we can import logistic regression. So input logistic regression. And then we need the function accuracy score. So from SQL dot metrics input accuracy score. So this is used to find accuracy of our model. Okay. So these are libraries and functions we need. First we import numpy. So numpy is used for creating numpy arrays. So pandas. So pandas is used for loading our data numbers into table. So these are the pandas data types. So we'll discuss about that another time. So then we have so we imported from the library SQL, then we imported the logistic regression model, then we imported the function accuracy score. So you can press shift plus enter to run this cell and go to the next cell. Okay. So if you have any printing output, it will go here. Okay. Now let's do the data collection and processing step. So I'll just put a text here. Data collection and data processing. Okay, so we already uploaded the data. There are several ways to upload data in Collaborative. We can upload the data straight to Collaborative using numpy. So we can do it here. We can do a pandas data type. So I create a variable for the sonar data. I will be loading this data to a data type and I have named this data type as sonar data. So as you can see, I have input pandas as PD. So this is just like an abbreviation. So I'll be using this abbreviation PD of DCSV. So as I told you earlier, we have data file as a CSV. So we need to use the function DCSV. Okay. So now we need to mention the name of the file, name and the location of the file. So you can do it by you can go here and click here. So then you will see this option called as copy path. So this will copy the path and the name of the file. So we have to enclose the code and put it in this brackets. Then, so as you can see, we don't have a header file for this. So as you can see, we don't have any header file. So we have to change the name for the column, right? So there is no header file. So we need to mention in our data that there is no header. So header is equal to no. So let's shift plus enter. And then this loads our data to the pandas data type. Okay. Now let's have a small data data set. So I will just type show data dot array. So what this function does is it displays the first 5 rows of our data set. So I'll run this. So as you can see here we have first 5 rows of our data set. There are several columns. So as you can see here there are 59 columns, but actually it's 60 columns because in Python the indexing starts from the array. So totally we have 61 columns, and 59 columns we have 59 features, and we have in the last column we have R or not. So I explain like it's either or not. So it is a categorical variable. So this is the use of this get function. It tries to provide the first 5 rows of our data set. Now all the rows, let's try to see how many rows and columns are there. So number of rows and columns. So if you are not, if you don't understand any functions, you can just search on Google or let's see. So you want to know all the read CSV functions. So you just can go to the pandas dot read CSV. So this is the pandas official. So you can go here. So you will so you can see the use of this particular function here. So it is read comma separated value, CSV file equal to and supports optional editing file system. So you can do this for any function. So we want to learn what this function actually is. So these are the parameters. So we don't need all these parameters. So in our case, we are using two parameters which are path of the file, and we are equal to there is no error. Okay, so if you have any doubt about any function, you can search it in Google like this. Okay, so now we need to find the number of those columns. So we can use it. We can find it by using the function called as shape. So sonar data dot shape. So this gives us how many rows and columns. this. So totally we have 298 columns and sorry 298 rows and 61 columns. The last 61st column tells that is a raw or a minor data. 0 instance it is labeled as R. Okay. So let's say take instance for example in, and there are totally 298 rows. So 298 rows means there are 298 instances or examples of data. Okay. So and 61 represents the feature. So let's say for this 0 instance, so it is a value for one raw, and there are 60 features for this one raw, and it is labeled as R. Okay. So here is there are 298 instances. Now what we will do is, let's try to get some statistical definitions for this data. So data dot display. So this gives the mean, standard deviation, and other parameters for our data. Sorry, just make a small mistake here. So data dot display. So as you can see here, it gives the count. So count represents the number of instances we have for the 0th column. So like this we have all the way up to 59 column. So it gives us the count. So the number of values here, the mean of this column, standard deviation for this column, minimum value 25%, 58%, 78%, and what is the maximum value. So percentage meaning like 25% of the values are less than this 0.033 for this column, and 50% of the values are less than 0.02. So that is what percentage is. So for some use cases, it is really important for us to find this meaning of standard deviation. Right? It gives just make it from here. So okay, that for raw, and how many examples are there? Raw value counts. So this value counts function gives us how many raw and how many main examples are there. Okay, so I have to include one thing. So we just need to put 60 here. This 60 is only the column index. So as you can see here, the raw means specified with the 60th column. So I am specifying 60 and this value count. So we don't function. Okay. So why am I using Sona data? Because I have loaded this data frame into a variable called Sona data. So that's why I am using this Sona data and including the function with this. Okay. So now let's see how many raw. Raw main examples are there. So as you can see here, there are totally 111 examples are there for main and 97 examples are there for raw. So it is almost equal, so it is not a problem. So if we have data for one type of instance more than R, okay. So data string what is it? Dot group by 60 dot group by 60 dot mean. So now explain what is the means of this. So as you can see here, so we got the mean value for all the columns. For a mean we have the mean value for 0 column is 0.034, but for raw it is 0.022. As you can see here, there is quite a difference between these two. So this difference is really important for us because using this only we are going to predict whether the object is either a mine or a raw. Okay. So just found the mean for each of the 59 columns. Sorry, 60 columns. Okay. So the mean value for mine is these values and for raw is these values, and there is a quite difference between them. Okay. So this is really important for us. Now let's try to separate the data and the labels. Okay, so here the data meaning these numeric values, so these are the features, and then the last column is the label. So we need to separate this. How we are going to do that? Let's see. So just make a comment here. Separation drop column is equal to 60. So I am dropping 60th column. And if I am dropping a column, I need to specify the axis as well. So if I am dropping a row, I will be specifying the axis as 0. Okay. And let's put the label in the variable one. So data. So we need to use a square bracket here, 60. Okay. So what I am basically doing here is I am storing all the values in X except the last column. So I am dropping the 60th column and I am storing the 60th column in 1. Okay. Let's try to print and see this. So print. the variable y. So soma meter. So we need to use a square bracket here, 60. Okay, so what I'm basically doing here is I'm showing all the values in x except the last column. So I'm dropping the 60th column and I'm storing the 60th column here. Okay, let's try to print and see this. So print x, print y. So as you can see here, there are 15 more columns. So actually it's 60 column and it starts with 0 and the last label is in the variable column. So we have successfully splitted the data and the variables. Okay. Now what we will do is we will try to split this data into training and test data. Okay. So let's include the text here. Training and test data. We need to give some variable names here. It's string. So you can give any names here. So for convenient purpose, I'm giving this name to string. It's test. White string. So this order should be followed. So first we will take the training data and test data. Then we will take the labels of training data and labels of test data. Is equal to training test split. And we have to include this x and y here. So we are going to split this x and y into training and test data. So x comma y. So there are several parameters here. We will explain them above. So x comma y. Test size, which I have test size as 0.1 and start page. Start page is equal to and random page is equal to, let's say, okay. So now let's try to understand about these parameters. So we are going to split the data into x train and x test, y train and y test. So x train is nothing but the training data for this and x test is the testing data. Y train is the label of those training data, y test is the label of the test data. Okay. So now we are using the function train test split. Then in the parameters we have included x and y. So we are going to split this x and y into training and test data. So here we have the parameter test size. So test size, like if we give 0.1 means we need 10% of the data to be test data. Okay, say for example we add almost 200 examples. So what happens is 10% of 200 is 20, so we will have 20 test data. So that is the use of this test size. You can use 0.1 or 0.2. So based on the number of data. Okay, so here we will take just 10% of data training. The start page is equal to, so start page, when we are using start page, yes, we need to split the data based on rock and mine. Say for example, we need to have almost equal number of rocks in this training data and equal number of mines in the training data. Okay, so let's include this start page. So our data will be split based on the number of these two rock and mine. Okay, and then we have random state. So random state is to split the data in particular order. Say for example, if you do the same code and the code you include one, your data will be split the same way as my data is split. So if 2 here, so our data will be split in a specific way. And if you include 2 in your code, it will also be split in the same way. It is basically to reproduce the code as this. So I use 1. Okay, so now we can split the data. Okay, now let's try. We add almost 200 examples. So what happens is 10% of 200 is 20, so we will have 20 test data. So that is the use of this test size. You can use 0.1 or 0.2. So based on the number of data. Okay, so here we will take the 10% of data training. The start page is equal to, so start page, when we are using the start page, yes, we need to split the data based on rock and mine. Say for example, we need to have almost equal number of rocks in this training data and equal number of mines in the training data. Okay, so let's include this start. So our data will be split based on the number of these two rock and mine. Okay, and then we have random state. So random state is to split the data in a particular order. Say for example, if you do the same code and the code you include 1, your data will be split the same way as my data is split. So if I put 2 here, so my data will be split in a specific way. And if you include 2 in your code, it will also be split out in the same way. It is basically to reproduce the code as it is. So I use one. Okay, so now we can split our data. Okay. Now let's try to see how many training data data are there. So training sort here. So it is the original data without splitting into training and test. Meaning we have string drop shape and except drop shape. So I have this. So as you can see here, in the original we have 208 examples, and in the training data we have 187 instance, and in the test data we have 21 instance. Okay, so we have 21 test data and 187 training data. Now we need to train a machine learning model with this with this training data. Okay, now let's see how we can train our model. So model trainer. So we will be using a logistic regression model. So I'll create a variable for this model. So as you can see here, we have already imported the logistic regression function here. So model is equal to logistic regression. So that will load this logistic regression function into the variable model. Now we are going to train the model. So training the logistic regression model with training data. Okay. So for that we use the function model.fit. Here we need to include the training data and training label. Okay, which are string and waiting. Okay. So let's see what is this external one trainers so that you can understand. So by printing string train. So this is the training data. So extend is the training data, white line is the training label. So as you can see here, we have the data here. So totally there are 187 examples and 60 columns. And this is the label. So as you can see here, it is kind of random because if you are using a complex model like slope regression model, so that's why I have included model.fit extend over here. So when I run this, our model will be here. So if you are having a lot of data and if you are using a complex model like a neural network, it will take a lot of time. So here we are seeing a simple example of simple data, so it does not take much time. Okay, so our model will be trained. So these are some parameters of our model. Now let's see how our model is trained. So now let's check the accuracy score of our model. So now we are going to evaluate our model. So model evaluation. So we have imported the function accuracy score for it. So we will use this function to find the accuracy of our model. Accuracy, non-training data. So first let's find the accuracy on the training data. So what's happening here is, so we will use this same data, the data model as well. So we will try to use this model to predict these examples. Okay. So then we will use the test data. Okay. So what is the significance here is the model has already seen what is this test data, sorry, the training data, but it hasn't seen what is this test data. Okay. It is just preparing for exam. Let's say you are preparing all the exam problems in the mathematics book for your exam. So those exam problems are nothing but the training data. So in the exam, a new problem will be and you need to solve that, but you have never seen that question, right? So that's nothing but the test data. So we need to test the model for accuracy of training data and accuracy of test data. So it is always in most of the cases accuracy of training data will be more because the model has already seen this training data, and most of the times the accuracy of test data. So the accuracy of your model is somewhere greater than 90 equal, it is actually good. So it also depends on the amount of data you use. So I don't data, so if you use many data points, and if you use a better one, you will get a good accuracy score. Okay. So if we use quite less number of data as we have in this case where we have only 200 data points, our accuracy can be low. Okay. So the idea of this video is for you to understand how we can clean up these steps. So the accuracy is not that much important, but we have to know here. So any accuracy greater than 90% is low. Okay. So now let's try to predict the training data. Let's try prediction. Is equal to model.predict string training data accuracy. So we will store this accuracy value on this variable training data accuracy. So training data accuracy is equal to accuracy score. So this is the explanation as a prediction of model makes. Okay, based on each learner. So we need to include external prediction. and all the correct values. It is right here. So what happens here is we are going to compare we are going to get the accuracy score. So extra prediction is the prediction of our model and what is the real answer of this test. So as we know here, so we have this test data, right? So x test and y test is the label of this test data. So now what happens is we are going to compare the prediction of our model and the original label of these data. Okay, by that we will get the accuracy score. So let's try to get the accuracy score for training data. So I print the accuracy score. So accuracy on training data. So copy this. So this the accuracy score here. Training data accuracy. So you can see that we got almost 83.4% of accuracy. So it is actually kind of good for these many data. So now let's try to find the accuracy score of their data. Okay. So it will be the same part except for some changes. We just need to include the test data. So accuracy of test data. So it's test prediction. Test data accuracy. So the model has never seen the data. But it's model not ready. Let's just okay. So like that. So now we are using our model to predict that this data and this prediction of this model will be compared to the original labels which is right there. Okay. Here's data accuracy. Now we need to print this accuracy score. So accuracy of their data. Here's data accuracy. So we got 76% as accuracy score, which is really good. So which means out of 100 times it can predict 75 times the correct object, whether it is a rock or a okay. So we got accuracy score as 88% for training data, 76% for test data. So our model is performing well. Okay. So now what we are going to do is, so we have trained logistic regression model, and now we are going to make a predictive system that can predict whether the object is either rock or it is mine using that sonar data. Okay. So now let's see how we can make this predict. We got accuracy score as 88% for training data, 76% for test data. So our model is performing well. Okay. So now what we are going to do is, so we have trained logistic regression model, and now we are going to make a predictive system that can predict whether the object is either rock or it is mine using that sonar data. Okay. So now let's see how we can make this predictive system. So let's see predictive system. So I need to give the input data. So I am making a variable for this input data. Okay. So in this, we need to include the sonar data. So we have seen this sonar data. So we'll be taking some examples for rock and mine, and we'll check whether our model is predicting the rock and mine correctly. Okay. So this is the use of this code. So once I complete that, we'll copy some values and put it, and let's see whether it's predicting correctly. So input data. So once we get the input data, we have to convert it to an array because the processing and numpy array is faster and it's more easy. So it's basically changing the data type to an array. So I used to an array. So changing the input data. Just like a command here. So changing the input data to an array. So we'll use the function numpy for this software. So input data as numpy. So this is the variable I am giving it. So input data numpy is equal to numpy.asArray. So if you remember, we have imported the library numpy as numpy, so I am using np instead of numpy. Okay, so numpy.asArray input data. So basically, we are converting this list into a numpy array. Now, let's take an example. Say for example, then I open this from my notepad. Okay, so let's take some background example. Okay, let's take it. This rock. So as you can see here, this example is rock. So if we feed this data to a machine learning model, so we need to predict that this is a rock. Okay, so I copy this. Okay, so I put this in this input data. So we have totally 60 features. So I have added this input data. So this is basically a list. So we are adding it to a numpy array. Okay, now we need to initiate the data. Okay, so we because we are just predicting for one instance. So for that purpose, we need to reshape this array, or otherwise model can be confused by the number of data points. So we need to reshape the numpy array as we are predicting for one instance. Okay. So input data reshape is equal to, I'm copying this input data numpy array. So we need to reshape this. Reshape one command instance. So this number of instance represents that is one instance, and we are going to predict the label for this one instance. So that's why we are reshaping this. So once we reshape it, we need to make the prediction. So I will create a variable for this prediction, and as well the prediction of model. So model.predict function is used to predict. So we are stored our plain logistic regression model in the variable called as model, as you can see here. So I'm calling the model function, so model variable, so model.predict this input data. So this contains the features of our data. Okay, so this data is present in the input data shape. Okay, so basically what happens is that this model dot returns either or m as array. Okay, so no result whether it is either or array. Okay, now let's try to print this prediction. Let's try to replace. So to predict that this object represents a rock because we have copied the data for a rock, right? Okay, now let's try to print this prediction. Let's try to run it. So to print that this object represents a rock because we are copying the data for a rock, right? So run this. And we have predicted correctly that the object represents rock from this example. Okay. And let's include the if condition here that if we get R as our prediction, it should say that the object is rock, and if we get M, the object is rock. Okay. So as you can see here, this R is included in this. So data of rock. So we have imported the different degrees regression model. So we are importing the logistic regression function from SQL data function in the number of row pieces in mean values. Okay, so I can see here there is a different mean value of rock and mean for each of the column. Okay, so now we are splitting the data into all the features that on the variables. So we are feeding all the features to the variable x and all the values to the variable y. Okay, now we are splitting our x and y data into training test data. Okay, so training data is used to train our model, and our model is evaluated with the result of test data, right? And then we are loading our logistic regression model in the variable model in the XPR program. So this is how these are all the procedures we have used in this video. So I hope you are clear with all these. So I will be giving the studying for the one.
Let's start with this problem. Find the mean, median, mode, and range of the following data set. Now, the first thing that I would recommend doing is arranging the numbers in increasing order. So the lowest number is 7, and we have 2 of them. After that, the next number is 10, and then 14, 15, 23, and 32. Now, to calculate the mean, what we need to do is we need to take the sum of the 7 numbers and divide by the 7 numbers that are in the data set. So this is going to be 7. In this video, we're going to talk about how to calculate the probability of a binomial distribution. So here we have a problem where a 6-sided die is rolled 12 times. What is the probability of getting a 4 5 times? So here's the formula that we need. The probability of getting X successes is equal to the combination formula NCX, which can be written that way. To the n, we need to determine 4 things: n, x, lowercase p, and lowercase q. So what are the values of these 4 variables? What's n? N is the number of tries. The 6-sided die is rolled 12 times, so n is 12. Now, how many successful events are we getting in this problem? We want to get a 4 5 times. So we want to successfully get a 4 5 times. So there's 5 successful events that we're trying to achieve here. Now, what is the probability of getting a successful event? What is the probability of rolling a 4 using a 6-sided die? So out of the 6 numbers that we can get, there's only one successful number, which is a 4. So the probability of rolling a 4 is 1 out of 6, because it's one number out of the 6 numbers that we can get. Now, let's calculate Q. What is the probability that the event will fail? What is the probability that we will not get a 4? Out of the 6 numbers that we can get, 5 of those numbers does not represent a 4. So the probability of not getting a 4 is going to be 5 out of 6.
This is data. If you are
Now let's talk about how to calculate. This is 11 times the formula to a approximately correct if with a die. So that's the probability of getting a 4 5 times if we roll a 6-sided die 12 times. Number 2, getting a 4 multiple choice test contains 20 questions with answers. Answer choices A, B, C, and D. Only one answer choice to each question represents a correct answer. find the probability that a student will answer exactly 6 questions correct if he makes random guesses on all 20 questions. So go ahead and take a minute and try this problem. Times the n minus x. Now, what are the, n is the number of tries. In this case, the a question is going to be 1 dx, 6 factorial, and so forth. P, x, 8, c, and b. 25% of all students, it'll be 1 out of 5 for P. Number 3, 25% of all students enrolled in high school XYZ are taking algebra. 30 students are chosen at random. Part A. Find a probability that exactly 7 students out of the 30 chosen are taking algebra. Go ahead and work on this problem. So we're going to use the same formula as we've been using in the last 2 problems. So what is n in this problem? N is going to be the number of students that are chosen at random. That's 30. X is going to be the number of successes in n trials. So these are going to be the number of students who are taking algebra out of the 30 chosen. So X is going to be 7. P is the probability of selecting a student who is taking algebra, and that's going to be 25%, or 0.25. The probability of selecting a student who is not taking algebra, that's going to be Q, which is 1 minus P, which is 1 minus 0.25. 30 and 7 times 0.25 raised to the 7th power times 0.75 raised to the 30 minus 7 power. So at this point, you know how to use the combination formula to calculate 30 C7. So I'm just going to use my calculator to get this answer. 30 C7, that is a huge number. It's 2,035,800. We're going to multiply that by 0.25 raised to 7 times 0.7 is approximately 6. And work on that example. What is the probability that fewer, not generally has to be less than 5, but a range of values for x? So x has to be less than 5, which means it can be 1, it can be 2, 3, or 4, but not 5. It's not less than or equal to 5, it's just less than 5. So what we're going to have to do is calculate the probability when x is 1, 2, 3, 4, and then add them up in order to get this answer. So let's find a probability that exactly 1 student out of the 30 is chosen at random who is taking algebra. So n is going to be 30, x is 1, p is still the same, it's 0.25. So it's 0.25 raised to the x is 1, q is the same, 0.75 raised to the n minus x, or 30 minus 1, which is 29. So this is going to be 30 c1, hopefully you have a calculator that can do that, times 0.25 times 0.75 raised to the 29th power. And so you should get 0.00178858. Multiplying that by 100, this is approximately 0.1786%. Now, let's calculate the probability that out of the 30 students who are chosen, exactly 2 are taking algebra. So this is going to be 30 C2, 30, this point is 7th power. 0.42. That's going to be, if you have an inequality, such as fewer than 5, you need to calculate multiple values in this case. So you have to calculate the probability of getting 1, 2, 3, or 4 students out of the 30 who are taking algebra. As you can see, this could be a long repetitive process, and if n is very large, you could use the binomial distribution to approximate a binomial distribution. But for this particular example, since we only need to calculate 4, I just decided to add all 4 values. Now, let's move on to part C, the final part in this video. So how can we calculate the mean and the standard deviation of this binomial distribution? How can we do that? The mean is going to equal the number of trials times the probability of getting a successful event. And in this case, it's 30. We know that P is 0.25. So it's 30 times 0.25, which is 7.5. So it's 30. And in this case, it's 30. We know that P is 0.25. So it's 30 times 0.25, which is 7.5. So as you can see, it's very easy to calculate the mean if you know n and p, which is given to you in the problem. Now, to calculate the standard deviation, it's not that difficult either. It's the square root of n times p times q. N is 30, p. Now, how would you answer this question? What is the probability of getting the first 6 on the 4th row using a 6-sided die? Of getting the first 6 on the 4th row using a a 6-sided die. You need to realize that this is a geometric distribution. You're trying to find a probability that a successful event will occur on the 4th try. So during the first row, you're going to get a failed event. During the second row, it's another fail. But during the 4th try, you're going to get a successful event. Now, we're dealing with a 6-sided die. And so if we have a sample space, these are the numbers that we can get if we roll a 6-sided die. So what is the probability of not getting a 6? The probability of not getting a 6 is there's 5 numbers that are not 6 out of the 6 possible numbers, so it's 5 and 6. So that's the probability of not getting a 6 on the first try. The probability of not getting a 6 on the second try is 5 out of 6 again. And for the third try, it's the same. Now on the 4th try, we want to get a successful event. We want to get a 6. The probability of getting a 6 is 1 out of 6. So we have 3 failed events, which is 5 over 6 to the 3rd power, times the probability of 1 successful event. So that's 5 to the 3rd divided by 6 to the 4th. 5 times 5 times 5 is 125. 6 to the 4th is 12 by 6. So if we divide those two numbers, that's going to give us 0.09645. Multiply that by 100, this is approximately a 9.6% chance that we can get the first 6 on the 4th row using a 6-sided die. Now for those of you who would like to use a formula to get the answer, here it is. So the probability of getting, well, let's just say the probability of a geometric distribution, it's going to be big X is the random variable, little x is like the trial that you want to get a successful event. This is going to be equal to q raised to the x minus 1 times p. Now, lowercase p is the probability of getting a successful event. Q is the probability that an event will fail. Now keep in mind, q is 1 minus p. So in some textbooks, you'll see it written like this. So just keep that in mind. So to apply this formula in this problem, we have capital X, the random variable, little x, and that's going to be 4, because we want to get a successful event on the 4th row. Q is the probability of not getting a 6, which we said is 5 over 6. X is 4, so this is going to be 4 minus 1, times the probability of getting a successful event. In this case, successfully roll a 6, that's 1 out of 6. And so as you can see, this will give us the same answer, which is going to be 0.2, blue card that you see passing on this row. The probability of equals 7 times p, which is 0.15. You can see a blue card. And a probability of 0.15 times 0.7% chance at 7 feet. There we go. You encounter in this town is a teacher. Relation RT. So let's replace 0.04, and that is now keep in mind one. So that's the variant. So that's it for this problem. That's how you get 600 times your point variance and the standard deviation is going to be a teacher. Now let's move on to part B. Let's calculate the mean, variance, and the standard deviation. So let's start with the mean. The mean is 1 over p. So it's going to be 1 over 0.04, and that is 25. Now what about the variance? There's a simple formula we could use to calculate. It's sigma squared, which is 1 over p times 1 over p minus 1. Now keep in mind, 1 over p is the mean, as you can see here. So 1 over p is 25. And then times 1 over p minus 1, that's 25 minus 1. So this becomes 25. Time has a defect. Sample of the end, and that's number 4. 2% of all tires produced by company. XYZ has a defect. A random sample of 100 tires is tested for quality assurance. What is the probability that the 8th tire selected has a defect? So go ahead and take a minute and try this problem. So let's write down what we know. So what are the values of P, Q, and X in this problem? Well, 2% of all tires has a defect. So P is 0.02. That's the probability of selecting a defective tire. The probability of not selecting a defective tire is going to select. So there is a 1.7% chance of selecting a bad tire during the 8th trial, or during the 8th sample. Now, let's move on to part B. What is the probability that the first defect is identified among the first 5 samples? So how do we get that answer? So we need to calculate the probability where x is less than or equal to 5. So this is going to equal the probability where x is 1 plus when x is 2 all the way to when x is equal, where x is 1, plus when x is 2, all the way to when x is equal to 5. So we need to add up the individual probabilities to get this answer. The probability when x is equal to 1 is going to be q raised to the x minus 1, which is 1 minus 1, so that's 0, times p to the first power. For the second one, it's going to be q raised to the x minus 1, 2 minus 1, which is 1, times p to the first power. And then if we repeat, for the second, it's going to be q. The probability when x is equal to 1 is going to be q raised to the x minus 1, which is 1 minus 1, so that's 0, times p to the first power. When x is equal to 1 is going to be q raised to the x minus 1, which is 1 minus 1, so that's 0. The probability when x is equal to 1 is going to be q raised to the x minus 1, which is 1 minus 1, so that's 0, times p to the first power. For the second one, it's going to be q raised to the x minus 1, 2 minus 1, which is 1, times p to the first power. And then if we repeat the pattern, this is what it's going to be. So for the last one, it's going to be q to the fourth power, p to the first. Notice that the exponents always add up to x. When x is 3, you have 2 plus 1. When x is 5, 4 plus 1. So we already know what q is. Q is equal to 0.98. And p is 0.02. Now to make this easier, what we're going to do is we're going to factor p, since it doesn't change. Q to the first power is basically 1. So I'm going to have 1 times, plus q squared, plus q to the third, plus q to the fourth. So it's 0.02 times 1 plus 0.98, and then plus 0.98 squared, and then plus 0.98 to the third power, and then plus 0.98 to the fourth power. Go ahead and plug this in your calculator. I got 0.09607, which is approximately. Now, for those of you who might be confused on how I got this part of the formula, here's how you can get it. X equals x, first power. So you get q to the 0, p to the first. Let's say, and when x is 5, because what if we had to find the probability that the first defect would be identified among the first 20 samples? That would take a long time. It turns out that there's a simpler formula to get the same answer. It's p of a problem like this. So in this case, little x is going to be 1 minus q raised to the x. So this is the formula we want to use for a problem like this. So in this case, little x is 5. So this is going to be 1 minus 0.98 raised to the fifth power. So go ahead and type that in. This will give you the same answer of 0.09607. So make sure to add formula to your list of other formulas that you need to know. So now that we have this formula, so simpler formula, the problem. So you get q to the 0, the x fused on. So that's the probability that the first defect will be identified among the first 5 samples. Now for those of you who might be confused on how I got this part of the formula, here's how you can do that. So let's say you determine p of x equals 1. Remember, p of x equals x is q to the x minus 1 times p. So when x is 1, this is q 1 minus 1 times p, which is always going to be p to the first power. So you get q to the 0, p to the first. Let's say when x is 4, this is going to be q raised to the 4 minus 1 times p to the first power. So you get q to the third, p to the first. And when x is 5, this is going to be q 5 minus 1 times p to the first power. So it's q to the fourth, p to the first. Just in case you're kind of confused in terms of how I got these values. So it all comes from this one. Now, is there an easier way of getting the answer? Because what if we had to find the probability that the first defect would be identified among the first 20 samples? That would take a long time. It turns out that there's a simpler formula to get the same answers. And here it is. This is known as the cumulative geometric distribution function. And it's p of x where it's less than or equal to little x. That's going to be 1 minus q raised to the x. So this is the formula you want to use for a problem like this. So in this case, little x is 5. So this is going to be 1 minus 0.98 raised to the fifth power. So go ahead and type that in. This will give you the same answer of 0.09607. So make sure to add that formula to your list of other formulas that you need to know. So now that we have this formula, we can use it to calculate the answer in part C. What is the probability that the first defect is detected among the first 10 samples? So this is going to be p of x is less than or equal to 10. Using this formula, it's going to be 1 minus 0.98 raised to the 10th power. And so the answer is going to be 0.182927. So that's approximately an 8.3% chance that the first defect will be detected among the first 10 samples. Now what about part B? How many tires would you expect to test until you find the first defect? How can we find the answer to that question? So go ahead and think about it for a minute. Pause the video for a moment. The answer is the mean. All we need to do is calculate the mean, and that's going to determine the number of tires we expect to test until we find at least one defective one. So the mean is 1 over p. And the probability of finding a defective tire is 2%, 0.02. So 1 divided by 0.02 is 50. So in fact, find the answer is the mean. All we need to do is calculate the mean, and that's going to determine the number of tires we expect to test until we find at least one defective one. So the mean is 1 over p. And the probability of finding a defective tire is 2%, 0.02. So 1 divided by 0.02 is 50. So we should expect to test 50 tires until you find one defective one, because that's the mean. So that's it for this problem. Number 5. 2% of all tires produced by company XYZ has a defect. A rare sample of manufactured tires is tested for quality assurance. Calculate the following. So go ahead and try this problem. It's based on the previous problem. So what is the probability that X X is less than 7. What is the probability that we're going to find a defective tire within the first 6 samples? So keep in mind, it's less than or equal to 6. So now we can use this formula. P of x less than 7 is turned this expression to p 0.98, and p is 0.02. And that is going to be 0.11466 is equivalent to this expression into something like this. Because this is 1 to 6. So we can say that p of x less than 7 is equivalent to p of x, which is less than or equal to 6. So now we can use this formula. So this is going to be 1 minus, now keep in mind q is still 0.98, and p is 0.02. So this is 1 minus 0.98 raised to 6 power. So there is, now let's move on to beyond x is on the y-axis, the random variable x on the x-axis. Now this is going to range from 0 to infinity. But for this problem, our focus is 12. This region here, let's separate it into 2 parts. The region on the left represents the probability where x is less than or equal to 12. The region on the right represents the probability that x is greater than 12, but not equal to it, since we included 12 on the left side. Now, the area under this curve from 0 to infinity has to equal 1, because that's the most that probability can be equal to. So if we add these two values, this is equal to 1. Now what I'm going to do is, I'm going to rearrange this equation to get this one. But first, let's write it in terms of little x. So taking this term, moving it to that side, we have the probability that x is greater than x is equal to 1 minus the probability that x is less than or equal to little x. Now, we have the formula for this expression, which is what we have here. So this is going to be 1 minus qtx. Now let's distribute the negative sign. The ones will cancel, giving us qtx. So the probability that x is greater than little x is simply q raised to the x. So now we could use that to get the answer for part B. So this is going to be 0.98 raised to the 12th power, which is 0.78472. So there's a 78.5% chance, approximately, that a defect will be found beyond the 12th sample. So the defect will be found between sample 15 to sample infinity. Now let's move on to part C. So what is the probability that the defect will be found from sample 18 to sample infinity, or x is greater than or equal to 18? So we're going to use this formula again, but we need to change it into this form. So this is between 18 to infinity. So we could say that we're looking for the probability that x is greater than 17, because this does not include 17, but it includes everything beyond 17, which is, once again, 18 to infinity. So now we can use this formula. This is going to be 0.98 raised to the 17th power. And so that's going to be 0.70932. Or we say that there's a 7.9% chance of finding a defect beyond the 17th sample. Now, let's move on to part D. What is the probability of finding a defect between sample 15 and sample 30? To get this answer, we need to draw a picture. So let's say 15 is here, and 30 is in this region. This is going to be 0, and that's infinity. So let's break this graph into 3 parts. We'll call this region A, B, and C. So the area of the curve for region A will be the probability where x is less than or equal to 14. For region B, that's what we'll do. That's going to be from 15 to 30. So let's say 15 is here, and 30 is in this region. This is going to be 0, and that's infinity. So let's break this graph into 3 parts. We'll call this region A, B, and C. So the area under the curve for region A will be the probability where x is less than or equal to 14. For region B, that's what we're looking for. That's going to be from 15 to 30. And then region C, it's going to be beyond 30, so we're going to start with 31. Now, these values must add up to 1, because the probability from 0 to infinity has to be equal to 1. Our goal is to calculate this value here. So let's rearrange the equation to solve for this expression, which means these two expressions need to move to the other side. So I'm going to erase this picture at this point. So we can say that the probability of finding a defective tire from sample 15 to sample 30 is going to be 1 minus p of x is less than 14 minus p x is greater than 31. Now let's get rid of this, and let's focus on calculating these two values for p. We're going to have an equation to solve for this expression, which means our goal is to calculate this value here. So let's rearrange it because the probability from 0 to infinity has to be equal to 1. Our goal is to calculate this value here. So let's rearrange the equation to solve for this expression, which means these two expressions need to move to the other side. So I'm going to erase this picture at this point. So we can say that the probability of finding a defective tire from sample 15 to sample 30 is going to be 1 minus p of x is less than 14 minus p x is greater than 31. Now let's get rid of this, and let's focus on calculating these two values first. So what is the probability that x is less than or equal to 14? So what's the formula that I could use for this one? So it's p of x is less than or equal to x, and that's equal to y minus q to x. So this is going to be 1 minus q, which is 0.98 raised to the 14th power. And so that's going to be 0.24636. Now let's calculate the probability that x is greater than or equal to 30. So this is the same. This is the same as x is greater than 30, because that will still be 30 to infinity. So we're going to use this one. It's simply q to the x. So that's going to be 0.98 to the 30th power, which is 0.54548. So now the final answer for this problem is 0.20816. So we could say that there's a 20.8% chance of finding a defective tire between sample 15 and sample 30. Now let's move on to the last part, part E. So let's calculate. The probability that a defective tire will be between sample 20 and sample 45, but not including sample 20. So this goes from sample 21 to sample 45. So this is going to be 1 minus the probability that x is less than or equal to sample 20, sample 46, and then minus the probability that x is greater than 45. So this includes sample 46 to infinity. So make sure you don't include a sample twice. So this includes sample 46 to infinity. So make sure your notice is greater than 45. So this includes sample stats from 1 to 20, infinity. So make sure you don't include a sample twice. So that I got the wrong answers. So this is going to be 1 minus point, and that's 0.332 raised to 45. Now using the second formula, we can calculate the probability that x is greater than 45, which is 0.98 raised to 45. Calculate the probability that x is greater than 45, which is 0.98 raised to 45. And so that's going to be 0.40288. So the final answer is going to be 0.26473. So there's approximately a 26.5% chance that we're going to find a defective tire between sample 20 and sample 45, but not including sample 20. Now let's take a minute to review the formulas that we've covered in this video. So what's the first one? The probability that x is equal to little x. This is where we get a successful event after a certain number of failed events. And this is going to be q raised to the x minus 1 times p, where p is the probability of a successful event and q is the probability of a failed event. Now we also said that the probability that x is greater than little x is q to the x, and the probability that x is less than or equal to little x, that's 1 minus q to the x. Now what about the probability that x is equal to or greater than x? In this case, all you need to do is subtract x by 1. So notice the similarities between these two formulas. Because by adding the underline, you're introducing an additional 1. Now for this one, which is similar to this one, where x is less than little x, it's going to be 1 minus q raised to the x minus 1. Now the remaining three formulas that we covered are the mean, which is 1 over p, the variance, which is 1 over p times 1 over p minus 1, and the standard deviation, which is the square root of the variance. But you can also use this formula together as well. It's the square root of 1 minus p over p squared. In this video, we're going to talk about how to use the Poisson distribution formula in order to solve problems. So take this problem for example. A small business receives, on average, 12 customers per day. What is the probability that the business will receive exactly?
In this lecture titled Visualization Technology, we're going to look at various ways by which visualizations can be classified. Typically, these visualizations can be classified based on forms, which is what mostly you would come to know. That visualizations can be like bar graphs or charts, a bubble diagram, scatter plot, and so on and so forth. Right? This is what most of us are familiar with. That's one way of thinking about visualizations, mostly the formal qualities of the visualization. The second classification is based on intention. Right? What do you want to do with your visualization? Is it to communicate? Is it to persuade? Is it to discover? Depending on that, or is it to instruct somebody to do something? Depending on what you want to do, you can also think about a visualization that will lead to that intent, or that will lead to fulfilling that intent. The third type of classification is based on the user experience you want to provide to the user. You want to provide an interactive experience. You want to look at a tangible experience where visualization is not just only through the visual senses, but also through an audio sensor, perhaps even touch, sensory, and so on. So these three ways of classifying visualization is very useful to think about how to go about designing visualizations. In the second part of the lecture, I'm going to introduce to you a simple yet powerful framework for designing visualizations, and then I'll round off this lecture by talking about the difference between data visualization and infographic. This is sometimes used interchangeably, but there is a difference between them, and it is important that we know that going forward when we talk about visualization in our future topics. So we'll get started with the second topic for the course, which is visualization typology. Okay, so in the first class, and so forth. Right? This is what most of us are familiar with. That's one way of thinking about visualizations, mostly the formal qualities of the visualization. The second classification is based on the intention. Right? What do you want to do with your visualization? Is it to communicate? Is it to persuade? Is it to discover? Depending on that, is it to instruct somebody to do something? Depending on what you want to do, you can also think about a visualization that will lead to that intent, or that will lead to fulfilling that intent. The third type of classification is based on the user experience you want to provide to the user. You want to provide an interactive experience. You want to look at a tangible experience where visualization is not just only through the visual senses, but also through an audio sensor, perhaps even touch, sensory, and so on. So these three ways of classifying visualization is very useful to think about how to go about designing visualizations. In the second part of the lecture, I'm going to introduce to you a simple yet powerful framework for designing visualizations, and then I will round off this lecture by talking about the difference between data visualization and infographic. This is sometimes used interchangeably, but there is a difference between them. It is important that we know that going forward we talk about visualization in our future topics. So we can get started on the second topic for the course, which is visualization typology. Okay, so the first class we tried to answer some of the questions remember why do we visualize at all. We convey information through a visual representation in order to, from a very simple map or summarize to inspire, advocate, persuade people's, change people's mind, and tell a compelling story. Right? And it could fall anywhere in between them. And, so today's lecture is going to be about what are the different ways by which we can think about visualization and design in a more systematic manner, right? So what are the methods, frameworks, processes that are available to you, okay? Because in a course, a formal course like this, we don't want to be just designing anything, right? Which is exactly what you did in your first exercise. I just do you and then you to come up with a visual representation, right? And you did not have a framework to think about how to go about designing for it, right? So it is where the framework is going to be useful, right? You know what the framework is, right? It's a process of automation. Be assured that there is some kind of quality is met for your work, okay? So that the things taken care of in some steps and so on. Then the students will also heard about it, right? In the design process, where you convert, where you generate ideas at some point of time, diverge first and then convert, and then make design and reach a solution. One of the most common design framework model that is available to you is the cyclical model, right? Which is you design, prototype, test, and then go back to design again, and then do it in a cyclical manner so that in every iteration you will have a direction towards an optimum solution, right? So these are very, there is nothing like one model is the correct model, right? Because these are just processes, right? It's a process tool. Think of somebody talks about frameworks most of the time, but not ourselves as a shoot, right? Which is clearly modification of an existing model, right? And then a lot of people who always tweak models at PhDs on these frameworks to come up with better models, which is modification of an existing model. Okay. The whole of the question are models the best I can get existing models, so you can come up with that just to see how you think about not tables. It's always one direction, and not variable. Several factors that represent two trains versus something that can also 10 more trains into the same representation. The way that you think about the solution is also different, right? Okay, so now we can divide or classify visualization based on several factors, right? Now, one of the ways that we can classify is based on the form, okay? The form qualities of the visualization. How does it look, right? What shape it has, okay? So, can tell data visualization time series data, the performance is indicated over a period of time. Then the feature lines that I just standard along the feature will start and finish line, right? So, any kind of component data has a very linear function, right? You can imagine that. In fact, yesterday you worked out that, right? At least one variable of your data has some component, right? That time is always linear, right? It is one direction, and you cannot rearrange it in further branches and so on. Okay. Ring charts, which are where the origin is in the center, rings are at the bottom. So you can have a radius in the center. So you have one single origin which branches to maybe 4 or 5, which further branches to 12 or 15 spaces back. Parallel called as Sankey diagrams and so on. Okay, so you can find more examples of this form of classes at this link. Okay, so you can find more examples of this form of classes at real life physical locations and overlay familiar map with different data points. Okay, so flow maps of your smart variation. Okay, so that starts a little bit. You can customize the colors based on geospatial data. Right, so they could intention be very different. So trends, times you want to show intentions are particular located. So two charts are different. So you look at you're using similar kind of charts that you use in the common but the intentions are different. The intention is that you want to show part of the whole. Okay, I want to show this distribution to classify the experience that you want to give to the user, right? So you can just narrative approach. The objective is to explain by giving the reader experience into the story. Okay, so you can how stars, say, how did it could be provide how smart it is not as even okay. More the framework for classifying the visual classroom. It was very in 2016 in the Harvard Business Review. Eventually, he went to write the idea. Okay, simples exercise. Right? You start and then right. So this is something that we understand intuitively. We also use metaphors, trees and bridges, for example. Trees have branches. And the objective is to use data visualization language in order to illustrate the mind. Okay, so you know the idea behind the curve, right? So what initially the experts thought was that we need to delay the process of everybody getting sick. Okay, because this was an unknown virus. They thought that everybody will get sick, but if everybody is going to hospital at the same time, all everybody will be sick, right? So what initially medical experts thought was that we need to delay the process of everybody getting sick. Okay, because this was an unknown virus. They thought that everybody was going to get sick. Okay, everybody turns up in delay the process of everybody getting sick. Okay, because this was an unknown.
All you need to know machine learning in 2024 is a laptop and a list of the steps you need to take. I'm a senior researcher working for an ex-Smith professor and have had interviews with Google, Amazon, and other cool companies. But it took me over 3 years to get to this point. So today I will share how I'm a professor and have had interviews with Google DeepMind, Amazon, and other cool companies. But it took me over 3 years to get to this point. So today, other cool companies. I would learn machine learning if I could start over by revealing the 6 key steps you need to take. Let's get going. In general, all these steps don't have to be strictly completed in any particular order. What I do highly recommend is to start with learning the basics of Python. Every other list form also have to, so much is already automated. You will need to know all fundamentals of calculus, linear algebra, and probability theory, complex maths. Most of the maths is high school or entry-level college computing resources out there that are free, like these courses right here, or a website called Canvas Networks, so through you onto them. You can always revisit it by just Google out the ML developer stack. So now you know books and maths with maps. Learn.plotly is a great tool for data and all learning, as you will see at analysis. Like some theories online, everything should honestly not level you already are. The most famous machine learning course or collection that you hear, all you do have to pretty much let it teach a in ML concepts and those transform the series enough. Since Andrew of background parties neural network series. He here implements a simple NLP model from the ground up and goes all the way up to a transformer. He also goes through all the maths of backpropagation and so on. Since you already get some practical experience with the taught ML concepts, I will then continue on to the next, more advanced and practical course, the Deep Learning Specialization. This more advanced and practical course, the Deep Learning Specialization. This more advanced and implement NLP, where NLP comes directly. Then you also learn even more challenges. Well, it's specific challenges that all
So today's topic is quite interesting and it might get a bit controversial if you take what I say to your heart. Like, don't generalize this to your startup or to your big company. So every now and then I have this one message in my inbox which is, I have an offer from a startup, I have an offer from a big company. Kahan jaun? And I'm like, main kaise batau? I don't even know you. How can I take this call on your behalf? So for that reason, what I'll be doing is, I'll be talking about this particular topic in depth. I'll be teaching scope and how about waiting. Let's get started with the first one, which is structure. In most of the big companies, very well defined. SD1, SD2, SD3. SD1 to SD2, 2 to 3 years or 1.5 years, 2 to 3 years. SD2 to SD3, 3 to 4 years or 2.5 years to 4 years. It's very well defined in bigger companies. Talk about startup, you don't know. I've seen people who are extremely talented be a teenager in 1 year. That is never going to happen in a big company. You can write that down. Perfect. So that is never with people who are extremely talented, be a tech lead in 1 year. That is never going to happen in a big company. You can write that down. Perfect. So that was about the structure where you will find in a big company. Stability. In a big company, the job is wide stable. Again, if you take the layoffs into account, you might have a point to make, but then I'm talking overall. Like overall, the last couple of decades, I think you're often working in a stable. But then if your startup is not performing well, or if the startup didn't get the funding expected, they end up doing a lot more layoffs, silent layoffs, which you might not hear of. So that was about stability. So before I move ahead to the meet, I learned a mentors from top 30 so check out there and read by starting your free trial. You can have I'll be very brutal on this. Learning opportunities at a big company is absolute shit. I do talk to people who work at startups. Dude, they have some amazing set of knowledge, which people working at bigger companies, they don't have that wider scope of knowledge. They're very into deep at a certain topic. Because at bigger companies, you don't get to work at a lot of things. You work on a certain thing and you go very deep into it. But when we talk about a startup, they get to work on a lot of things and they do go into depth. So, learning wise, it's very exponential in a startup, whereas in a big company, it's a linear curve. No offense, it's a linear curve. Again, people might not agree with me, but again, it is something which I'm saying, taking everything into account. Might be certain companies, might be certain teams where you can learn a lot. That's not the overall scenario. What about the scope of work? Now, in big companies, you get to work, but you might not get to work on something which ends up going into production tomorrow. Whereas in a startup, you might get to work on a feature that you have called on, like you have decided that this is a feature I want and people agreed in your team and you coded it tonight and it might go tomorrow, like when people are using it, and the next day you might be scrapping it off as well. In a big company, you don't get to call on the feature. There are other people who do it, they do the market research, they decide on the feature, and then you work on the feature, and then it goes live, and then there's a product team which takes over. So on the scope of work, you get a lot more to call on in a startup. In a big company, you're very chill, you don't do a lot of things. Someone comes up and says, do it, you do it, and it goes live. The scope of work, I think, in a startup, you get to work on a lot more things. Perfect. Let's come to the next thing. Career growth and advancement. Talk about career growth. It's very subjective. I cannot pinpoint this. I know one thing for sure. 10 years down the line, if I'm working at a big company, I'll be at a certain position. I'll be having a certain salary. I'm very sure about this. Now, at a startup, you're not very sure because you're not sure about of the startup. Unless it's a big size startup like Subaru, you can